part. Okay. Good.
Okay. Thank you.
Yeah. Okay. So hello all. Today's session is all about revision of week 5 and week 6 content. So okay. So we will quickly go through on the concepts and then we will try to solve some questions. Okay. So uh, I will not go into that much deep, which usually we do in our open session, and also it's you want any derivation or any deep discussion. So that I would suggest you to rewatch the open session. Anyway, if time allows, I will do that part as well. Okay, so this is just key idea about today's session is to revise the concepts of week 5 and week 6. Okay. By the way, is the preparation started to all of you, or you are about to start, or if it started, then how is it going on for quiz 2? I think next Sunday is the quiz 2 exam, right?
Yes, sir. There has been a mock quiz that has been released, so it's looking into those
Okay.
questions.
All right. All right. What about others? Very few people are joined. I think if there is any. Everyone got the announcement, right?
So what is the announcement?
Yes, sir.
Announcement for today's revision session.
Yes, sir.
So if there is any group and all, then you can inform. We are about to start so that everyone can join. Okay, so I got only one comment from one person. What about others? Have you started or you are about to start, or so what's the idea?
Sir, this week I'll complete week 8, so then after
You are
that,
going to start, huh?
yes,
So
sir.
today's schedule is okay to revise week 5 and week 6?
Yes, sir. Yes, sir.
Okay. So we thought
Yes.
to split the sessions, not to revise week 5 to week 8 simultaneously. So we thought we'll split 5 and 6, so that see if we are revising this weekend, and so that if you have any doubt or any concept is missing, then you can go through those concepts this weekend, and next week you can focus on week 1 and week. It's up to you how you are preparing, but that's the our idea to split the revision session in 2 parts. Okay, so
And the syllabus is from week 1 to week 8, right?
yeah, it's week 1 to week 8. Major
Okay.
portion will be from 5 to 8.
5 to 8. And
Yeah.
how much will be the weightage on the week 8?
Weight is something we are not disclosing. This is
No,
just
no, that's okay. I was just curious to understand. Will week 8 also will be as intensive because week 8 is coming very close to the
yeah,
exam
week
date.
8 will be there. Week 8 there will be questions from week 8 for sure.
Okay.
Yeah.
Okay.
So you do not ignore week 8. Okay. So week 8
No,
is
no.
one of the important
Yeah.
uh, concepts or content you can say for our students.
Sure. Sure.
Don't worry, there will be formula set also. Just one thing you need to take care of how to apply those formulas, right? So there is nothing you have to, memorize all the formula. Maybe you have seen the formula set in quiz 1, right? In quiz 2, we will update the formula set accordingly as per the syllabus of quiz 2. Okay, then you can focus on this.
Sir, I think probably I didn't explain my question. So what I was trying to ask is, when you look at the quiz 1, we had week 1 to week 5, right?
Correct.
And in the week 5, there was a level of questions of week 5 were mostly either less intensive or a moderate, not a very complex one.
Yeah, it was very
Will,
simple,
will this
variance part.
will this be the same situation for week 8 also, or you will be having a more complex, high level
No,
questions
it's
in
not.
week 8?
I won't say it will be complex. So I think
Okay.
this mock and revision session will be more than enough for week 8 concepts.
Okay, right. Thank you very
That
much.
that's something I can say. So because
Okay,
we know the
that's what
question.
I was asking. Yeah, that's what I was
So,
asking.
yeah. Okay, all right, no problem. Okay, so should we start or any other doubt, or if there is anything else, we can have a general discussion at the end. So since we don't have any session after it, so we can extend the session. Don't have any. Okay, all right. So let me share my screen. Is my screen visible to all of you? Can you see? Can you see the PDF?
Yes, sir.
Okay. So I have collected some questions which have been asked in previous videos. So we will solve those, but before that, I would like to quickly go through the content. Just a quick brush up on the concept. Okay. Does this sound good, or should I jump to question part directly?
Go with your flow, sir,
Fine,
as
no worries.
usual.
Okay.
Yeah.
All right. Okay, so in between, if you are getting any difficulty, do let me know. And any one of you have doubt in from let's say AQ, PA, and all from any other concept, those things we can discuss at the end. Okay? But I hope that throughout the discussion we will do, it will be enough for you guys. Okay, anyway. So the key concept for the week 5 and week 6 for your quiz 2 is the first we will start with the functions of continuous random variable. Okay. Then second we will jump to expected value of a function of a continuous random variable. One more thing I would say, please do not rely only on the PYQ, because some people, what they do, they simply just solve the PYQs and they used to go for the exam, but do not rely on the PYQ itself. You have to put some efforts also. PYQ will give you some idea, but do not completely rely on the PYQ. You have to put some effort.
So what
One thing I
do
can
you do?
say, one thing I can say, if you have done the GA, PA on your own means from your effort, do not, I mean, you didn't copy from others something else. So that will be more than enough. So next we will discuss, I mean, after expected value of continuous random, we will move on the discrete continuous, I mean, basically joint distribution of discrete and continuous random variable. Okay, this is also important from these two point of view. Then, okay, so these are the main concepts of your week 5. Okay, then week 6, I mean, the fourth content is will be the jointly uh, continuous random variable. Okay, then we will move on the independence part. So these all things you have seen in case of discrete random variable, right? I mean, joint PMF and all, yes or no? Then we will see the how to calculate marginal PDF, then conditional densities of continuous random variable. Okay, so the key idea is, so this is the major topics of uh, your week 6. Okay, all right, so let me start.
Sir, in the week 6,
Mhm.
do we have Marcos and Chevier's inequality also similar to week 4 or
In
5?
week 6, no Markov inequality, right?
Okay.
No, I'm
Yeah, I was,
asking, is the Markov is in the syllabus or?
no, no. For the discrete, we done that. Do we have for continuous also? We'll have similar inequalities
Actually,
or?
Markov and Sebicev, if I'm not wrong, it's in week 7 or week 8, right?
Okay.
Yes, week 7, sir.
Week 7, right?
Week
Yeah, so
Log
7.
see,
Okay.
for continuous, it's there.
Okay.
you can say the only thing. See, if you know how to calculate expected value of x for a discrete and the same
Yeah,
for content,
it's the same thing. Okay, okay,
bound is
right.
same, right? I mean, formula is the same. So, like,
Formula is same. Okay, okay. Right. Thanks.
yes, Chandan, you have any query? No. Okay. Okay. So let me start the thing. So first thing is the how to start. So very first thing is CDF of the function of continuous random variable. Okay, so we will see how to start with. If you have any function of the continuous random variable, the key thing is you can start with the CDF part. Okay, there is one important theorem, we will see that part also. So what is this concept, the CDF of function of the random variable? Suppose I'm saying let x be a continuous random variable. This is the continuous random. I mean, this random variable x have the CDF given to us f of x. Okay, capital F of x, and with PDF small f of x. Okay, this is the something suppose is given to us. So there is a function g. Okay, from R to R. Okay, this is the function. In this can be any function, right? It can be x square, 3x square, x cube, anything. Okay, so the thing is how to start with this. Okay, so suppose I'm saying now, suppose y equal to g of x. Okay, now this will be a random variable. Yes or no? So this is the another random variable. Okay, with CDF capital F of y. Now, how to calculate this CDF capital F of y? So you will start the formula of CDF. So this is something I can write probability y less or equal to small y, right? And what is this capital Y represents? So this represents just a function of your x, right? Yes or no? Now, what is the next task? And you what you can do basically at the end, you have to find. See, now this is something inequality you will get in terms of x, right? And you have information about your random variable x with CDF and PDF, and you can apply. If you know, you can integrate. You can integrate. If you know the CDF formula, you can apply the direct CDF formula, and at the end you will get the answer for this CDF of your random variable y. Okay, so if you know, if so you got the CDF, you know how to get the PDF. Yes or no? If you have CDF, how will you get the PDF?
We do differentiation.
This is the differentiation. Okay. Should I take the example for this, or can I move?
Can you please take an example, sir?
Okay, no problem. So let me take very simple example. So suppose I'm saying x is from uniform.
Sir, I have a small request.
Mhm.
There is a easy example of activity question number 1. Would you take that example?
Which activity question?
Fifth week activity question number 1.
It be simple. Then you're not able to do it.
No, I am not able to do it. Something strange is occurring.
Sorry, whatever.
No, it is not matching with the answer.
Which question?
First question, activity 1, question number 1.
This one.
Yes, sir.
See, this is based on the formula. I will come to this. Don't worry. This is in this question you can directly apply the
Monotonic formula, but that
yeah.
formula is giving wrong results. It is
See,
showing
1 second. What's your good name? I didn't
Snap.
discuss the formula itself. Wait for a
Oh,
minute, right?
I'm
I'm
sorry, sir.
going with the flow.
I'm
Okay.
sorry, sir. Sorry, sir.
Okay, let me go with the flow. If after discussing the formula, I will take example. If you don't have, if you didn't get any clarification, let me know then. Okay. See, if session is going in a flow, it will be beneficial for you if you are watching it later as well. Okay. Anyways, I will come to that. Don't worry. So suppose y equal to gx, I took as a 2 times of x. Okay. So my question is, what is the CDF of y? Okay. Now, so how to start? So basically, so see, so here if you see in the question, it is simply asked what is the CDF of your y, right? So what I will do, so you know, right? If x is from uniform a comma b, then what is the PDF of f of x? 1 upon b minus a,
Upon b minus a.
right? So in this case, what it will be? 1 upon 2 minus or minus 1. Yes or no? Which is 1 by 3.
Yes, sir.
Are you getting? So see, at the place of a, it's minus 1. In the place of b, it's a 2. Are you getting 1 by 3? How did I get this 1 by 3? Yes or no?
Yes, sir.
So this x is from between 1 and 2, and it will take value 0 otherwise. Now, what is the CDF formula in case of if x follows uniform? So very simple, right? X minus a, basically. So if it is below a, it will be 0, right? And if it's inside the support of, x is inside the support of this random variable a and this. If x is between a and b, what is the CDF formula? X minus a divided by b minus a. Are you getting what I'm writing here?
Yes.
Yes, sir.
Now, so we have information about x. Then what will the CDF of x here? Tell me. See, x follows uniform minus 1 comma 2. What will be the CDF here? If x is
X plus,
Then x plus 1 by 3.
so it will be basically x minus a. So x minus or minus 1, which is, it will be x plus 1 divided by 3.
3.
Right? After 2, it will be 1, right?
Right.
Now we have to calculate the CDF of y, right? So we know how to start. So CDF of f of y is nothing but I can write probability that y less or equal to y, correct? So this capital Y is the information about your random variable. This small y is the one of the instances of this random variable y. So what is this y? It's a 2x less or equal to small y. Now after this, I can write x is less or equal to y by 2. Yes or no?
Right.
What is this? This is f x of y by 2.
Well,
Yes or no?
Correct.
So this is one of the value, right? You can think as a value. So instead of small x, I have small y by 2. Correct? So what will be the, if I will apply this CDF formula, if I have capital Fx of small x, this is something I can write as x plus 1 divided by 3. Then what it will be? It will be y by 2 plus 1 divided by 3 or not?
Yes.
Correct?
Yes.
So basically this will be y plus 2 divided by 6.
Right. Yeah.
And what will be the support of y? If x is from minus 1 to 2, what will be the support of y?
minus 2 to
Minus 2 to
Minus 2 to
4.
4, right? Minus 2 to 4, this will be support of y. Correct. So if you see, what is the support of y? Minus 2 to 4. So now, this is the case. Can I write y minus or minus 2 divided by 4 minus or minus 2? Do you agree with me?
yes.
Yes, sir. What is this
Yeah.
now? Can I say
That-
y follows uniform minus 2 comma 4 or not? Simple.
Yes. That's something from y minus a by b minus a.
B minus a. Is it clear now? Yes, no?
Yes.
Okay.
Sir, sorry to interrupt. How you get that y support minus 2, 4? Is it in the given in the sum? Is it?
No. So y is defined as a 2x, right?
Okay.
If
Okay.
x
Okay.
is
So
minus
you're just
1,
putting the
so
value
y
of
will be
x.
minus 2 to
Yeah.
4, right?
Okay. Thank you. Got it.
So the one of the
Okay,
important
Sir, 1 second, sir. So this last step which you done now.
Mhm.
So f of y
Mhm.
that is the CDF of y.
Correct.
Now, what is the final value of that CDF of y?
This one, this y plus 2 divided by 6.
Y plus 2 by 6 at a base of minus 2 to 4.
Yeah, so this is something I got. I just changed like this just to give you the idea why this is uniform. So one more thing you can do here. See, this part, if you will differentiate, what you will get? Tell me.
1 by 6 only.
1 by 6?
1 by 6.
See, if I would like to write, suppose I want to write a small f of y. So what else I can write? D upon dy fy of y. Would you agree with me?
Yeah.
This is what? 1 by 6?
Correct.
Right? What is this? Can I write 1 upon 4 minus or minus 2? Since I know what is the support of y? Now, what this formula, if you relate, this is something
The PDF.
PDF of uniform random variable or not?
Okay.
Understood?
Yeah. But do we really need to do that step, or is it only for
No,
understanding?
I'm just giving the idea.
Okay.
See, suppose.
But in the exam, we don't have to prove that it's end result
don't.
is
Or
uniform.
suppose it's some MSQ is given to you. Okay, in one of the options
Okay.
this is given to you, one of the options this is given. You have to select.
Okay.
That's all.
Fine.
So I'm just trying to give you an idea. If you know the
Understood.
PDF, if you know the CDF, then you can get idea. Okay, see,
Sure,
if in your mind you have the PDF formula of uniform, within a second you will get to know, oh, this is something looks like uniform, right? And you have formula set.
Okay.
If you don't recall the formula, you can cross check from there. Okay.
Sure. Okay.
Yeah. So one of the important theorem from week 5, also from your quiz point of view, which is we also discussed in our session. This is called monotonic differentiable function theorem. So I know maybe some of you will get bored because the same thing I'm writing again and again. Okay, so just be with me. Maybe this will give you some idea. So what is the theorem? Let me write. So theorem says, suppose X is a continuous random variable. Okay. So this is given to you, and since this is a continuous random variable, this will be having with PDF small f of x. Okay, and let g of x. Okay, this is something be a monotonic function. What is the monotonic function, anyone?
It's either strictly increasing or strictly decreasing.
Decreasing, right? This is the monotonic function for the support of x. Okay, so suppose I'm saying, so for the support of x, so this will be monotonic for the support of x. Okay, with the derivative, and this will be differentiable also. So these two things we have to check. If this okay, what is this? So g dash x, this is nothing but the function g of x should be differentiable. Okay, then the PDF of y. This PDF of y, I mean the function of x, is directly you can apply this theorem. Fy of y is nothing but 1 upon g inverse of sorry, what's that? This would be g dash g inverse of y into fx of g inverse of y. So what you have to check, the for the given support of your random variable, function should be monotonic as well as if you don't have anything, please try to mute yourself. Okay, all right. So for this question, since someone asked from the activity this question, right? 3x square 0 to 1.
Yes, sir.
Okay, so this is, so let me take this example. So what is the PDF given to us? F of x is defined as
3x square.
3x square. And what is the support of x? 0 to
1.
And it will take value 0 otherwise. And function is y equal to x square. Okay, so function is defined as a y equal to x square. We have to find the PDF of y. So this is g of x, right? This is g of x is given to you. First of all, if you see the what is the, we need to check. So what is the graph of x square basically? So graph of x square, I'm just drawing for the support of x. So support of x, suppose this is 0, this is x. So this will look will be graph of x square. Would you agree with me?
Yes, sir.
Are you
Yes,
getting my point?
Yes, sir.
Right? So this is monotonic or not? This is monotonic. It's increasing in the
Yes.
support of x 0 to 1.
Yes.
It's monotonic.
Right? So it's a monotonic as well as this is differentiable, right? Yes or no?
Yeah.
This
For
is
continuous
Different,
and
Yes.
differentiable.
this is differentiable, right? So first of all, if this is the g of x is y is given to us as the x square. So if you see from the formula, what else I can write from here? Tell me. G of x is x square.
because
First
G
of all,
inverse x is 2x.
G inverse y is root x.
one second. So what will be the g dash of x? This will be 2
2x.
times of x.
6x.
No, g dash of x. We have to differentiate this function, not this function. This
2x.
x square is the
2x.
function. See,
2x.
3x square is the PDF, right? Okay.
Yes, sir. Yes,
So
sir.
instead of x, what else I can write? So see, if you see from here, if you have y equal to g of x, so can I say x is nothing but g inverse of y? So what is the meaning of this? We have to replace the values of x in terms of y. So what is g dash of g inverse y? Tell me. We have to replace this x in terms of y. What will be the value of x here from here?
2 root y.
2 root
Root
y.
y.
Root y only,
Root
right?
y. Root y.
Yes or no?
Yes.
So this will be g dash x will be 2 root y,
Right.
right? So far so good. Now we got this part. We have to think about this part. So what is the f x of x? This is 3x square, right? So what is the f x of g inverse y?
3 times 2 root y square. 3 times
No.
y,
So what
where
is
is
the g inverse y? G inverse y is the nothing but x.
x. Yeah.
Basically, it will be 3 times of square root of y, right? We have to do x square. X square is what? X square root of y square. That is y. 3y only, right? So far so good. So what is the PDF of y? So according to formula, 1 upon absolute value of g dash of
Dash of
g
G inverse
inverse
of
y into fx of
fx of G
g
inverse of
inverse y. So this will be 3y divided by what is this? This value is 2 square root of y. So if we cancel out, this will be 3 by 2 square root of y. What will be the support of y from here?
0 to 1.
0 to 1 only, right? Now is the option B option is correct?
Yes, sir.
Right? You got the idea?
Yes, sir.
Okay. All right.
Sir, in this example, when you are finding g inverse y, in the g dash case, we have to use the y is equal to x square for finding the g inverse y. But in the other case, f of x case, we have to use the 3x square for finding out the y value. Sorry,
Yeah.
x
So
value.
see, just think about this small x. This small is one of the instances about your random variable, right? So here, if it's a
Right.
small x, capital X represents your random variable, right? Small x, if it's small x, it's 3x square, right? I want convert this small x in terms of y, right? So what is the value of g inverse y? G inverse y means
root
what?
y.
G inverse y means what?
Root-
I want
root
to
y.
root y, right? G inverse
Right.
y is the root y basically. So I will substitute root y square, which is 3y only.
Oh,
Okay.
okay.
Oh, sir, we differentiated g dash x with respect to x and then substituted x with the value root y.
Correct. So see, if you have information about x, right? So gx is what? This is just a function of your random variable.
Okay.
All right.
Mm-hmm.
This is the function of random variable. So what is the g dash x? Gx is simply x square. What will be g dash x? So this is nothing but I have to differentiate this g of x with respect to x, right? If you see the theorem. All right. So this will be, if you differentiate, you will get 2 times of x. So g dash x is nothing but 2x. Now I have to replace the all values in all x in terms of y. Clear?
Okay.
Okay.
Not I will not differentiate g inverse of y with respect to g. Right.
No. Say don't go. Say do not make too much complicated things, right? So here you can see it's simply I'm talking whatever the function is there. I have to differentiate it with respect to x. That's all.
Okay.
Very simple. Okay. Okay. So should we jump to the next topic? Or should I take any other example? Let me take another example. Okay, very simple example again. So suppose I'm saying x follows exponential with parameter lambda. Okay. Okay, or else let me solve this question. Yes. Okay, let's solve this question. Here B is the correct, but just apply and tell me whether you are getting the same answer or not. Okay, so I'm giving you some 3 to 4 minutes. Just solve this and let me know.
So would you please zoom it?
First of all, this x cube is monotonic in the given support of x or not?
Yes, sir, it is.
It's a monotonic,
Yes, sir, it
right?
is.
That,
It's
this
between
means you
0
can
to 1.
apply the theorem directly, right?
Yeah, it's 0 to 1, right?
See, usually x cube, if you see, this is not monotonic, but for the given support of x, this is monotonic, right?
Yes, it's an asymmetric function. For the whole domain, it won't be. It
For
won't be monotonic.
the whole domain, it's not. Right? For the
It's,
given
yes.
this particular support, it's there.
Sir, yes, sir. Option B is right.
Option B is right. Okay. What about others? Are you trying? Should I wait for a few minutes or should I continue?
Yes, it's fine. Yes.
Should I continue or you want to try?
Sir, we want to try, sir. Give me
Okay.
1 minute.
Okay, all right, no problem.
Yes, sir. Second is correct.
Sir, there are a few type of questions where we need to find
Yes, sir, continue.
using expectation and variance, the transformation of one function to the other. Could you solve such questions also?
Like you are talking about expectation of function of random variable, right?
Yes, sir. For reference, you can go to the graded assignment. One of the questions is that I'm talking about those questions.
Let me complete. First, it's all about expectation, right?
It includes expectation. I don't remember the question, so we have to do it in that method. It's not
Okay,
about
no worries.
expectation.
Okay,
Okay,
we'll see.
sir.
We'll see.
Yes, sir.
Sir, what is the answer, sir?
Which option you are getting?
B and
B and
B.
Okay, B is the correct one. Okay, first of all, okay, let me solve. So this y equal to x cube, for this support of, you have to check the theorem, right? So for the support of x, the other things I have discussed, I will discuss other things in later. Okay, please do not interrupt with the general doubts in between. Okay, let's continue. So this is first of all, this is monotonic and differentiable. So this is something you have to put your effort, right, from your end. Do not rely on PYQ. You have to solve graded assignments and practice assignments from your own. That will be more than enough. So this is monotonic and differentiable for your given support of x. Okay, because something x, see, usually x cube graph is something like this, right? But for the support of x, this 0 to 1, this is the monotonic. Now this is monotonic, then I can apply the theorem. So fy of y will be what? 1 upon absolute value of g dash of g inverse y into fx of g inverse y. Would you agree with me? Now, first of all, what is this y equal to g of x equal to x cube? Then tell me what will be g dash of x? 3x square. Yes or no? And from here,
Yes,
what will be the value of x in terms of y?
Or
This
it
is
will
y
be
raised to power 1 by 3, right? And g dash x is 3x square. What will be g dash of g inverse of y? See, x means what? I have to replace in terms of y, right? So basically, what I'm trying to say here, if y equal to gx is something, so x is nothing but g inverse of y, right? That's what I want. So what will the value of x is? Y raised to power 1 by 3. So this will be 3 into y raised to power 2 by 3.
2 by 3.
So far so good? Yes or no? So this is one part we got. And what is the fx of x from the question? This is 4x cube, right? Okay. What will be the fx of g inverse y? Tell me.
4y.
4y raised to power 1 by 3 raised to power whole cube. This will be 4y. Yes or no? Now I can apply the theorem directly. So if you apply the theorem, so it will be fy of y is nothing but 1 upon absolute value of g dash of g inverse y into f of g inverse y. Depend this. Keep me present. Okay, so this will be 1 upon 3y raised power 2 by 3. All right, and this will be 4y, and this will be 4 by 3, and y raised power 1 minus 2 by 3. So basically 1 by 3, right? So the option B is the correct, and support will be 0 to. Is this clear now? Okay, so you can see you will get the simple. This is the one.
So how did we get the support 0 cube and 1 cube, right?
Yeah, that's what you have to substitute the values here, right? Okay.
Okay.
Yeah. So this concept is clear to all of you.
Sorry, scroll down, please.
Hmm. You are taking screenshot and all. Do not take. I will share this PDF. Don't worry. Okay, so the next concept is expectation. So what is the expectation and all? You have seen already in case of discrete random variable. Now we will see how to do in case of continuous random variable. So suppose x is a continuous random variable. Okay, and with PDF, in case of discrete, PMF will be given. Okay, then how to calculate the expectation of x? So expected value of x is nothing but we have to integrate this from the support of x. So let's as of now, let's suppose this is minus infinity to infinity. This is x into fx of x into that PDF. Okay, so basically this integral should exist. Okay, that's what. Now, so this is for random variable x. So suppose in case you have been given, I mean, suppose this g of x, a function of random variable is given to you. Okay, any function of random variable x is given to you, then how will you calculate the expected value of g of x? Okay, one more thing, can you tell me, in case of discrete random variable, how did you calculate expected value of x square?
X square px xy.
Summation of x square into px, right?
Yeah. Probability of x is equal to x.
Now what you will do, you will integrate this same thing, function of x into fx dx. That's all. Okay. So if this is suppose x square, it will be integral of x square into fx dx. That's it. Okay. Is this all right?
Sir, once could you repeat this point, sir, last g of x point?
See, g of x is any function of your random variable. Okay. So if x is discrete, you are calculating like this, right? You are adding summation of x. In case of continuous, you can substitute the gx. See, how you what is the expected value of x in case of, I mean, suppose this is just x, so it will be integral of x into fx dx, right? If any function of any function g of x is given to you, so expected value of g of x will be integration of minus infinity to infinity gx into fx dx. Okay, so for example, I'm saying suppose x square is given to you. Okay? So x square is one of the function of x, right? So this will be integration of x square into fx dx. So this fx is the PDF. You have to integrate this for the support of x. That's all. Okay. So I will take very simple example. Don't worry.
Okay, sir. Yes, understood, sir.
What is support of x?
See, it's okay. So support of x, basically you can see the where x is lies. Okay. For this interval, the PDF should be strictly greater than 2. In simple
X
terms,
is
in case
valid,
of
sir. We can say.
yeah, in case simple terms, in
The
case
limit
of
of x.
discrete, you are saying the range of x, right? Here it's the
Mhm.
support of x.
Okay, okay. Thank you.
Okay, so very
Sir,
simple
one-
example.
sir-
Let me take, yes.
So one question, sir, here. So for x, you have a certain support, but when you are using a function, the support will change. We should use as a change modified support
No,
or
it's
same
for
as.
x because you are talking about x only, right? The PDF is
Ah,
okay. Let me take very simple example from the display. Suppose x is, I'm saying it's a 1, 2, 3. Okay, what is the corresponding probabilities? It's, let's say 1 by 3, 1 by 3, 1 by 3. Okay, what you will do in case of expected value of x? Summation of x into probability x equal to x, right?
correct.
Probability is same for x.
Yeah,
Now,
yeah.
if I will say x is square, then what you will do? Summation of x is square into probability x equal to x.
Okay.
You are
Same,
just squaring the values, right? And
Okay.
here, rather than doing summation, we are going to integrate, because continuous is all about continuous summation. Basically, that continuous summation we have replaced with the integrals. That's all.
Okay.
Clear?
Right. Thanks.
Yeah. So I will take very simple example. Suppose x is the continuous random variable, and with PDF, some PDF. Let me take PDF, something like this. Fx of x is nothing but, let's say, 2x plus 1 divided by 2. Suppose this is, and so x is lies between 0 and 1, and it will take value 0 otherwise. So my question is, your first is, let's start with the find expected value of x. How will you proceed? Okay, so expected value of x is nothing but expected value of x. How I will do? X into fx of x dx, right? This is clear.
Yes,
Right?
sir.
Yes, sir.
So what is the support of x here? 0 to 1. Right? Now this will be 0 to 1, and x, what is the f of x here? 2x plus 1 divided by 2 dx, right? So 1 by 2 you can take outside because this is just a constant, right? So now this will be, can I write 2x square plus x? Would you agree with me?
Yes, sir.
Right? Next task is, can I write 0 to 1 2x square dx plus 0 to 1 x dx? Yes or no? Now this would be 2 I can take outside. So what will be the difference? Integration of x square, it will be x cube divided by 3. Yes or no? Plus here, see, this is x power n dx is what? X power n plus 1 divided by n plus 1, right? Yes, no?
Yes,
Yes,
sir.
sir. Yes, sir.
See, like this.
So the x
So this
three
will be x
obviously.
square by 2, right? 0 to 1. Okay, so what is the next task? I have to substitute these values. So this will be 2 into 1 by 3 and minus 0 cube. So this will be 1 by 3 minus 0 only, and it will be 1 by 2 minus 0. Correct? And if you solve this, it will be 1 by 2 in bracket 2 by 3 plus 1 by 2. So basically this will be 7 by 12. Correct? Is this clear? Yes or no? So the next is, suppose I'm saying y equal to x square is given to you. You have to find the expected value of y. That means, suppose you have to find the expected value of x square. Then what you will do? Expected value of x square is nothing but integration of x square into fx of x dx. Right? That's what we have to do. This will be 0 to 1 x square, and it will be 2x plus 1 divided by 2 dx. All right. So this will be 1 by 2, 0 to 1, and this will be 2x cube plus x square dx. Yes or no? Are you getting this step? Whatever the things we have done.
Oh yes, sir.
Yes, sir.
Yes, sir. Yes,
Should I
sir.
solve this, or is it okay if I can skip?
Yes, sir. You can skip this. We can
Right.
integrate.
Right. So or let me do quickly so that I want to try to give you some idea. Okay, so this will be 1 by 2. If I will integrate this, this will be 2 into x raised to power 4 divided by 4, 0 to 1, and this will be x cubed divided by 3, 0 to 1, and this will be 1 by 4, 2, and this will be 1 by 2 again, 1 minus 0 plus 1 by 3, 1 minus 0. So basically, if you solve this, this will be 5 by 12. Okay, so this is something expected value of x square you got. What if I will say variance of x is how to calculate? Then variance of x will be expected value of x square minus expected value of x whole square. Right? So this is 5 by 12 minus 7 by 12 whole square. So whatever the value will be there, you will get the variance form. Okay, is the idea clear here? Okay, yes, no?
Yes, sir.
Okay. So the last concept from week 5 is called this joint distribution of discrete and continuous. I will explain that concept and then we will try to solve some questions from this week 5 concepts. Okay.
Sir, is there any quick question in the questions area for expectations, like previously how we solved?
From the question which whatever I have collected.
Yes, sir. Like
Okay,
we'll
don't worry.
solve
So
topic wise if possible.
yeah. So I thought let me finish this joint
Okay, sir.
part. Then we will what we will do. We'll try to solve the questions from these two topics, and then we will be done from the week 5.
Okay, sir. Yeah, sir.
Sir, a small request, sir. Sir, one topic in week 5 is the scaling and the shifting of coordinates. So that is
that comes under this discrete and continuous, right?
Okay, thank you.
No, I'm asking.
I might be. I don't know.
Okay, so scaling. See, it's very simple thing. So if you want do basically, if it's the same concept you apply. Okay, if you have calculated what will be the expected value of ax plus b?
A times ex plus b.
A x
That's
plus
all.
b.
This is something shifting or not, right?
Oh yes. No, one shifting problem I could not do. Activity 1, question number 7. We will come to it later.
This one.
Yes, I got by 12. How is it coming by 48?
Sir, this concept I was asking previously, there is a more complex problem than this in graded assignment which you can solve later if possible. After this discrete, could you solve that? It will give an idea for us.
Okay, for all right. Okay, let me quickly finish the
yes, sir.
concept, then we will move on this time. So here basically you can directly okay. Anyways, don't do this. Okay, we'll see that those problems. Okay. So what is this discrete continuous joint distribution actually? So I will quickly go through the concept from the called multiplicative rule. I will start from there actually. So what is the multiplication rule? If you see from the, I will talk about in terms of this two basically what to say this events, right? I will start in terms of events of events of A and B. Okay. So what is I can write A given B, probability of A intersection B divided by probability of B, right? From here, what else I can write? Probability of A intersection B, can I write probability of B into probability of A given B, right? This is one thing. Yes or no?
Yes,
sir.
Right. So what is the law of total probability? So if you say, suppose I have something like this. So suppose this is the B1 and this is B2. Something suppose A is here. This A is here. What if I will ask what is the probability of event A? So this means probability of A intersection B1 plus probability of A intersection B2. Can I say or not? And this part A, how will you calculate the probability of A intersection B1? Can I say probability of B1? B1 has occurred, and what is the probability of occurrence of A in the B1? Yes or no? Plus this probability of B2 into probability of A given B2. So far so good?
Yes, sir.
Right. So this probability of A, how can I write this probability of A? Let's say so this is something. Let's say I is equal to 1 to 2, and if I want to generalize, this will be probability of Bi and into probability of A given Bi. What is this? This is called something marginal probabilities. Yes or no? And this is conditional probabilities. Can I say? All right. So
Yes,
what do you do? See what is the key thing I started from here. So basically, suppose I'm saying x is a discrete random variable. X is the discrete random variable. All right, with some range, and let's say I'm saying this range is I'm denoting as a t of x, and since this is a discrete and there will be some probability mass function, let's say I'm denoting it px of x. Okay, now what is the idea? So suppose x is a discrete, so what is the key thing? So for each x, for each values of x, okay, whatever this value, this value will be from the range of x. Okay, what I'm trying to say, for each x, suppose we have a continuous random variable yx. Okay. Continuous random variable yx. So this, there is a interpretation of this yx. Let's say, what is the interpretation? Suppose if this is the continuous random variable, there will be some PDF of y. Okay, so what is the meaning of this y of x? So this y of x is nothing but this represents the y given x equal to x, the conditional part. Okay, so this y of x is totally means y given x equal to x. Okay, so x is the discrete. For each x, there will be conditional distribution, which is called which is the y given x equal to x. Now, what is the f y x of y? This is nothing but say conditional density. Okay, of is are the notations clear so far?
When you say condition density, it is a probability density, right?
Yes, says
Conditional probability density.
Conditional probability for each x, the something.
Yeah, yeah.
We solve some question that will give you the idea. So basically, this b1 and b2 you can think as a, let's say, x equal to some value. Let's say x1 is given to you, and x is taking only two values, x equal to x2, and this a is something. You can say this is the, what you will say. This a is what?
So y, right?
Y.
It's a continuous.
Y or y given x equal to x?
Y given
Y, right?
Y given x x equal to x1 or x,
Okay,
x equal to x2.
no problem. So in terms of events, I wrote probability, summation of probability of bi into probability of a given bi, right? This is something I wrote. All right. Now, in terms of, okay, so what is the key thing? What is, how will you calculate the marginal PDF of y, marginal distribution of y? First of all, this is the marginal probabilities for events B. This is the marginal probability of event A. Yes or no? Yes or no? So if you want to calculate the marginal PDF, marginal density of y, then how you can calculate Fy of y? Basically, this is nothing but summation over the range of x, and what you to sum the this all the probabilities, marginal probabilities into this conditional density. So basically, this is marginal probabilities of x, and this is the conditional. So are you able to relate with the events B, I, and A?
So our px is equal to like p of by,
Correct,
and
correct,
p of
correct.
a given b is
So
y
you can
given
think
x.
like this, something like, so there is B1, you can think, suppose x is taking only two values, x1 and x2. This is the discrete. For these two parts, there is something, y is occurring, y is something like this. Okay, then how to calculate this f of y, probability of y? Okay, marginal density of y. This is something you can apply the law of total probability. So law of total probability is the key idea behind this. Is this clear?
Yes, sir.
Okay, so let me take one of the.
Sir, is this a base theorem only in continuous distribution?
This is law of total probability. Base theorem will come later. Okay, all right. So let me take one example for this problem, and then we'll move on the other part. Okay, so suppose I'm saying x is let's say discrete uniform with two values, which is let's say -1, 1. Okay, and conditional y given x equal to -1 is given to us as a, let's say again, uniform. Okay, but this is the continuous uniform, -2, 2. This information is given to us, and y given x equal to 1. This is, suppose this is exponential distribution 5. So you can see, right, for each x, so x is taking only two possible two values, -1 and 1, and for each x there is a conditional densities are given to you. Yes or no? Now the question is, what will be fy of y? So fy of y will be what? So for each x I have to calculate. So you can think like this. So here suppose x is taking -1 and x is taking 1, and there is something y is occurring, right? So this will be uniform and this will be exponential. See, this is not a correct graph. I'm just trying to give you the idea so that you can relate the formula part here. So what will be here? What I'm trying to say, what is the probability that x is taking -1 into fy given x equal to -1? Okay, plus probability that x equal to 1 into fy given x equal to 1 at 1. Is this clear now? Yes or no?
Yes, sir. Just a moment, sir.
Clear? Formula is okay. So you can think like this. What is the probability of occurrence of A? Probability that B1 has occurred, probability that x equal to x1 is there, into conditional. I mean, given that B1 has occurred, what is the probability of occurrence of A? Or probability of B2 into probability of A given B2. The same thing here. This is probability of B1 into conditional probability plus probability of B2 into conditional. Okay. So now what is the probability of x equal to -1? It's a
1/2.
1/2, right? Because this is taking discrete uniform, so this is 1/2. And what is the conditional density? What is the PDF here?
1/4.
B minus A. So
1
it's
upon B minus. This will be
1
1/4,
by
right?
minus.
PDF will be 1/4. Yes or no? So this will be 1/4 plus. What about probability x equal to 1? Again 1/2.
1/2.
And what is this? Exponential 1/5. Then lambda
5.
into e raised power minus lambda.
Yes,
Right?
sir.
Will be 5 into e raised power minus 5.
5y.
That's all. This is the PDF of y. Clear?
Yes, sir. It's perfect.
Would you explain again 1/2 dot 1/4?
So this is uniform, right?
Yes, sir.
What will be the probability x equal to -1?
So 1/2.
1/2. What is this? So this is something I got, and this is conditional density when y given x equal to -1. What is the distribution when y given x equal to -1? This is continuous uniform -2, 2, right?
Yes,
And what is the PDF of continuous uniform distribution? It's 1 upon b minus a. So 1 upon 2 minus or -2 will become 1 upon 4. So this is 1 upon plus probability of x equal to 1. This is 1/2 into fy given x equal to 1. So what is the y given x equal to 1 is nothing but exponential 5. So what is the PDF of exponential 5? Lambda into e raised power minus lambda x. So what is the lambda here? 5 into e raised power minus 5y. That's all.
Okay, sir. Okay, sir.
Okay, clear?
Oh, clear, sir.
All right. So the next concept is called something you have to apply the Bayes theorem actually. Okay, so by using the Bayes theorem, you can find out the conditional probabilities here. Okay, so what is the Bayes theorem? First of all, let me give you a brief idea about Bayes theorem. Okay, so again, I will start from in terms of events. So suppose this is B1, this is B2, and there is another event A. Okay, so we have solved this. What is the probability of A? We solved this is summation over I by the law of probability. This is the summation of probability of Bi into probability of A given Bi. This correct? Now, the question is, by the using the Bayes theorem, what is the probability that I'm saying A has been occurred? What is the probability? It's in B1, right? So this is something I can write probability of B1 intersection A divided by probability of A. Would you agree with me? And the numerator part, I can write probability of B1 into probability of A given B1 by the multiplication rule. Yes or no? And divide by probability of A. Correct?
So this is exactly reverse of what we understood in the earlier
Yeah, this is the so this
concept, right?
in earlier we got to know what is the probability of A, right? Now my
provided B. Yeah, what is the probability of A provided B1 either B1 or B2 has occurred? That was the previous concept.
So the
Here,
question
what
is,
you are saying is, what is the probability of A occurring in either B or B1, B2?
I'm
B1
saying I'm saying A has been occurred. Okay, what is the probability that it's from B1? So
B1,
you can take very simple example. Suppose you can say, suppose there are two fridge. Okay, fridge 1 and fridge 2. And in fridge 1, suppose there are some white chocolate and some dark chocolate. Okay, and let's say again some white chocolate, some dark chocolate. Okay, suppose my question is, if I will ask, and suppose selection of this fridge 1 and fridge 2 for this both are same. Just assume. Okay, it can be different, but for simplicity, let's say 1/2. I'm saying, what is the probability of selecting a dark chocolate? What you can do? You will do probability of dark chocolate and it's from fridge 1, or probability of dark chocolate and it's from fridge 2, right? And you can apply the, suppose what is the probability, I mean, how will you split this D intersection F1? Probability that F1 has been selected, given that F1, what is the probability of dark chocolate, plus probability of F2 into probability of D given F2. Yes or no? This is something you can calculate probability of dark chocolate. Yes or no? Yes. Now let's change the question. Suppose I'm saying this dark chocolate has been selected. What is the probability? It's from fridge 1. Okay, so that's where this Bayes theorem comes into the picture. Okay.
Okay.
Bayes theorems, the earlier slide also back to back on, sir.
That's the law of total probability. Those two are different things. Okay. So why I started this Bayes theorem? So this Bayes theorem, so just so that you can relate. So basically, this is something I can write probability of B1, marginal probability of A given B1 divided by probability of A. So in this case, so suppose I'm saying X is discrete, okay, and Y is continuous, right? This is something we have been given information, right? This is continuous random variable. What is the probability that X equal to X given that Y is taking some specific value, let's say Y naught? So, okay, so what is this? This will be probability of B1. Basically, this will be marginal probabilities of your random variable X into conditional density of random variable Y and divide by marginal density of Y. So this is something you can relate with this Bayes theorem formula. Okay. Is the idea clear?
So here we are saying the random variable has occurred, event has occurred, and then we are finding in which discrete
case, yeah. For what values of X?
Case, this is applicable. Okay.
Yeah. So for this same example, let's try to solve this. This example, let me make it say this as an example star. So from the same example star, okay, let me write it, sir. So X was uniform, discrete uniform, -1, 1, right? And we have been given some conditional density Y given -1. This was the continuous uniform from -2, 2. You can identify this if square bracket is given, say continuous, and if curly bracket is there, then it's discrete only. Y given X equal to, and sometimes continuous we are denoting like this open bracket. Also, these two both are treated as same, and this is exponential 5, right? And then we calculated Fy of Y as what was that, summation and marginal probabilities of X and into conditional densities, right? This is something we calculated, and we got this part, right? These two part, correct? 1/2 into 1/4 plus 1/2 into 5 e raised power minus 5y, correct? Now let's change the situation. Suppose I'm saying you have to calculate what is the probability that X is -1 given that Y equal to let's say Y equal to -1. Okay, what will be the formula? By using this will be probability that X equal to -1. Yes or no? And this will be F Y given X equal to -1 at -1. Yes or no? And divide by F Y at -1.
Yes,
Are you
sir.
able to relate with the formula?
Yes, sir.
right? Now, what you here you have to think a bit, just a simple thought you have
Yes,
to
sir. It
think.
will be 1, sir, because exponential is not defined for -1 value.
Correct, correct. So the key thing is here, see, in general, fy of y was this formula, right? If you calculate fy of -1 here, so if you see exponential, this exponential is true then when y is greater than 0, right? This exponential PDF is valid, correct? If I'm asking fy of -1, then this part is true only. Are you getting? So I will get 1 by 2 into 1 by 4. And why is this is true? Because this is support is -2 to 2. Right here, x, y cannot take any value like -1 and all. So this because exponential is defined when y is greater than 0. This will be valid only. All right, so in the numerator part, it will be 1 by 2, and this fy given x equal to -1 is nothing but this part, right? So 1 by 2 into 1 by 4, because this conditional density y given x equal to -1 is uniform -2 comma 2, and divide by this is again 1 by 2 into 1 by 4. So you can see this is the one single. Okay, is the clear? Is this idea clear to all of you?
Yes,
No,
sir.
sir. No, sir. Please explain once more.
Where exactly you heard out?
One, how did it come? Means-
Because it got cancelled out. That's all.
No, no, but exponential was there, no. So we
So
added.
exponential, see what is the PDF of exponential? So it's lambda into e raised power minus lambda x, and what is support of this x should be
Okay, I
greater
got
than
it.
0,
I got it.
right? And here, see, we are talking about density of y at a specific value, right? Specific particular point, which is -1. So for this will not be true, right? This part will be 0.
Yes, yes.
That's all I'm trying to say.
Yes.
Okay.
Yes.
Okay, so we are done with the week 5 contents. So, do you like to discuss the questions or? Yes, no. Should we do the questions from week 5?
Sir, one question, sir. Instead of finding out x is equal to -1, say y is given that y is equal to 1. If the reverse is given, that if x is given as 1 and y is given as -1, then how do I go about solving it?
X is 1.
X is given to be 1
Just,
and y is.
just substitute the values, right? So if x is the 1 and y is the -1, so this will be probability of x equal to 1, right?
Okay.
Which is again half, and probability y given x equal to 1 and y is -1, right? This will be what? This will be again
0.
not 0.
1 by 4 times 1 by 2.
Whatever. Just no, y 4.
One.
X is 1, right?
Mm-hmm. X is 1.
So x is 1. This means what?
So half
You have
into.
to use this part, right?
Oh, yes.
But
Yes.
you have to see, if you are taking y as a -1, then it is going to be
0.
0, right?
Yes, yes.
Because in that case, it's not defined. Understood? So there is one interesting question. So I would like to give you some time, take 4 or 5 minutes and try to solve this question. Also, if you don't want to try, let me know. I will solve this problem.
Sir, is it option D?
We'll see. I don't know. Okay, so I got one vote for option number D. But I don't think option D should be correct because what is the good approach? Try to draw the graph first. Others are trying, or should I start?
Trying, sir.
Trying. Okay. Okay, Soundly Mukherjee said option B. Okay, so I got one vote for option number B. So I will wait for 1 more minute and I will start. Discussion.
Option B, sir.
Option B. Okay.
Option B. Option C, not B.
Yes. Okay. What one vote for option C? Okay, so I got 3 answers and all are different. Okay. Should I start? Yes. No.
Option B.
Option B. Okay. So seems like we'll go with option number B. Okay. So let's try to solve it. So here x is the Bernoulli point 4, right? This means x is the discrete. What is the possible values x will take? It's a 0 and 1 because this is a Bernoulli. Yes or no? And if it will take value 1 with probability 0.4 and it's taking value 0 with probability 0.6. So far so good.
Yes, sir.
One more thing, it's a y given x equal to x. So this means y, there is two possibility. Y given x equal to 0. So this will be uniform from -1 to 1. If you will substitute the value of x. Yes or no?
Yes, sir.
What will be the things in next case?
So that will be for x equal to 1, which will be 0 to 2.
Y given x equal to 1, this will be 0 to 2. Okay, so one good thing, see in this case, you cannot take directly -1 to 2 or -1 to 3. Sometimes people will say, okay, y is from -1 to 2, they will click this option directly. No, just for a safe side, just draw the graph, just to check whether there is overlapping or not. Okay, what I mean by that, so if you so option B is the correct. So if you will draw the density of this conditional density actually, let me draw that part. So suppose this is y-axis, this is 0, and this is suppose 0.1, 0.2. Okay, suppose this is 0.3 and 0.4, and suppose this is 0.5. So this is basically what is the y-axis? Y-axis is nothing but conditional density. Okay, so this conditional density y given x equal to x. Now on this here, so suppose this is minus 1.5, this is minus 1.0, and this is minus 0.5, and suppose this is 0, this is 0.5, then 1, 1.5, and then 2, then 2.5. First of all, in this case, minus 1 to 1, what will be the density? And what will be PDF? Basically 1 by 2, and here again 1 by 2, yes or no? So minus 1 to 1, minus 1 to 1, it's a 1 by 2, right? That is 0.5. Yes or no? So this minus 1 to 1, this is uniformly distributed as 0.5. Correct? Yes or no?
Yes,
I
sir.
get my point. And from
Yes,
0
sir.
to 2, it's 1 by 2. So from 0 to 2, if you see from 0 to 2, again it's 0.5.
Yes, sir.
Correct? So you can see there are split, right, in the range. So you have to see y from minus 1 to 0, from 0 to 1, and 1 to 2. Understood? Because you can see the
Yes, sir.
overlapping part, right? So what you have to do, basically, you have to just solve these cases. Basically, when if you see the when for y belongs minus 1 to minus 1 to 0, right? Yes. So minus 1 to 0. First of all, how will you calculate this part? Fy of y in this case, we know Fy of y, how we are calculating the marginal density. What is the probability of x there, and into conditional probability? Yes or no?
Yes, sir.
Yes.
That's what summation we are doing, right? Are you getting my point? So what
Yes,
you
sir.
see here, so here first of all, and what is the possible values of x? Possible values of this. Okay, let me write it like this. Summation x equal to 0, f y given x equal to 0 at y plus probability x equal to 1 into f y given x equal to 1 at y, right? So can you tell me whether x is for this minus 1 to 0, this part will be 0, right? Because this doesn't play any role. Yes or no?
Could you repeat, sir?
See, for this probability x equal to 1, if you are taking minus 1 to 0, if you are just thinking about this support first, which I'm highlighting with the red color, right? Is there any role of probability x equal to 1?
Okay, no, sir, because it's minus 1 to 1.
Minus 1 to 0, right? Basically, x, there's a role of x equal to 0 only, correct?
Yes, sir.
Okay, so what it will be? Tell me, what is the probability of x equal to 0?
1 only, sir.
0.6.
No,
Sorry.
probability of x equal to is 0.6, right?
Yes.
So it will be 0.6 into, what is this conditional density? Y given x equal to 0, it's 1 by 2, right? Which is 0.3,
Yes, sir.
right? So you can see for this part 0.3, that's all, right? You can directly select this option number B. But for safe side, just calculate all the options. So for when y 0 to 1, just think y is equal to 0 to 1. When y is in the part of 0 to 1, then what will be fy of y? So probability x equal to 0 in the conditional x equal to 0 at y plus probability x equal to 1 into fy given x equal to 1 at y. So there is a role of x equal to 0 and 1 both, right? In this case, x can
Yes,
take
that's an
0, x can take,
intersection.
right? I'm talking about 0 to 1 only.
Yes,
So
sir.
there is a role. So what this will be 1 by, no, sorry, 1 by 2. What is the probability of x equal to 0? 0.6
Yes, sir.
into 1 by 2 plus 0.6, 0.4 into 1 by 2. So basically it will be 0.3 plus 0.2, which is again 0.5, right? You can see this is matching. Now, when y is 1 to 2, there is again a smart approach. You have to think of it. So probability x equal to 0 into f y given x equal to 0 at y plus probability x equal to 1 into f y given x equal to 1 at y. So for this part, is there any role of x equal to 0?
No, sir. It is
No.
not defined. That's why it is 0, right, sir?
Yeah, it's not defined. So whenever you have undefined event, probability will be 0. That's all. Very simple approach.
Yes, sir.
Okay.
It's like the previous question where x equal to -1, where exponential is not available at
Correct, correct,
-1. Okay,
correct,
okay,
correct,
yes.
correct, correct, correct. So you have to think a bit. That's all. See, you can say concepts are the same, right? Just a change of this. So this part will be 0, right? This will be 0, and this is the again 0.4 into 1/2, which is 0.2. So you can see option number B is the. Is this clear?
Sir,
Sir,
can you please repeat the last
one doubt.
part? Yeah, sorry.
Yes,
Sorry.
yes. Please. Yeah, go ahead.
Why we got that 0.6? Could you please explain once again, sir?
X is the
Yeah,
Bernoulli,
there.
right? X is the Bernoulli. So
Yes, yes,
this is
yes,
success
sir.
probability, right? It will take value 1 with probability 0.4, or it will take value
0.4. Yeah, yes, sir.
clear.
Remaining part 0.6.
0.6. Okay.
Sir,
repeat, sir.
Last part, sir.
So see, this is
the
Bernoulli,
way
right? So if I'm saying X
Okay.
follows Bernoulli with P, this means X will take value 0 with X will take value 1 with probability P, and it will take value 0 with 1. That's all.
So the last part you mentioned, right? Can you explain that again? How are
This
you
one?
mapping that one? Yes, that 1,2 to this. You
See,
said that
here y is from 1 to 2, right?
correct.
So if you
Correct.
see, this is x-axis, right?
Last part. Yeah.
This is x-axis. If I'm going from 1 to 2, there is no possibility x can take value 0, right?
Okay.
So
Yeah.
that is undefined. If you undefined event, the probability for that will be 0.
Okay. So you're putting
Sir,
0.
values at x-axis are of y, na, then why are you saying x is not taking value 0?
Sorry, axis.
Sir, values at x-axis are values of y, no?
No. I didn't hear what you are trying to say.
Sir, you are saying na y belongs to
Sorry,
-1 to
basically
0.
this is y, this is y, and this is conditional density y given x equal to x. That's correct. If you see the formula, we have to do the summation of all over the x into conditional part, right? So for this, okay, let's say this is y. Okay, suppose this is y. So for this part, what's the rule of this case? Tell me whether this will be defined or not.
So no, here x is not taking the value 1. That's why. Yeah. Yes,
See,
sir. Here, x is not taking the value 1.
Actually, this x equal to 1 is not 0. I think there was some confusion. This x equal to 1 is not 0. This will be 0.4 only. This part is 0. Why? Because this is not true, right? Yeah. If you see, if I'm taking y equal to y, I'm going -1 to 0. Is there any possibility x equal to 1 will occur? Just think like that. No, right? Because this density is defined from -1 to 0 only, right? Are you getting? This conditional density y given x equal to x is defined from for -1 to 0 only. There is no role of y given x equal to 1. So I mean x equal to 1 not defined means this density is not defined here, right? Are you getting my point? So this will be 0. And when y is 0 to 1, in that case you can see this is defined and this is both are defined, right? Are you getting? And when y is 1 to 2, again there is no role of when y given x equal to 0. That will be 0. Okay, is the idea clear?
Where the values of x, sir? That's what not I'm understanding.
See, what is this?
This is the values of y, na, sir, -1 to 0.
Okay, can you define this part? In this part, -1 to 0, what will be this part? Y given x equal to 1. This y equal to x given 1 is what? Just think like this. This y equal to x given 1 is what? It's defined from uniform 0, 2, right? Okay, let's go with by the formula. Y given x equal to 1 is defined from 0, 2. Yes or no?
Sir.
Right. So from -1 to 0, is this possible? No, right? This density will be 0, right? This density is from 0 to 2. Then are you able to relate? Now from 0 to 1, both are defined. Just think like that. Now these two both are defined, right?
Because 0 is coming in both, sir.
That's what. So that's what if you see the graph I have drawn, the blue color and red color, right? Now, if you see the last part 1 to 2, that x, this rule will be 0. Y given x equal to 0, that density will be 0, right?
Yes, sir.
That's what I have done. Okay.
So this y equal to two ranges, right? Can you scroll up a little bit?
Mm-hmm.
So can you slightly up some more? So you have y at x equal to 0 and y x equal to 1, which
1.
are uniform, yeah, -1 to 1. So how did you arrive at this -1, 1, 0 to 7?
This is given to us, my x minus 1.
Oh, okay, okay,
So
okay.
x can take only two possible values, 0 and 1. If you substitute 0, it will go -1
So
to
then
1.
It will
0,
give
comma
-1
2.
and
Okay.
Sure.
Hmm?
The 0, comma 2, just up.
Yeah. What is the issue?
Now, how do you arrive this 0, comma 2?
What is this?
Oh, this -1.
X plus 1.
Yes.
X can take only two values, 0 and 1, right? If you take 1, it will be 1 minus 1, 0, 1 plus 1, 2.
Oh, got it. Sorry.
Okay. So it was given indirectly. You have to, okay. All right. Any issue? Okay. Clear, right? So you got the idea. Okay. Don't worry. In this quiz too, you won't get this much complicated question. Okay. So don't worry. But the basic things you have to be clear. The basic idea is written. Okay, so the now I'm going to jump for the week 6. So we are done with the week 5. Okay, so I will quickly go through the week 6 content, and then we'll try to take the questions from those topics. Okay, does this sound good to all of you? Okay, yes, no, anything?
Yes, sir.
Okay, so the next, the very important called the joint density. Okay. You have seen the joint PMF of two discrete random variable, right? So what is the joint density? So there is, this is called, suppose I'm saying there is a function f x comma y. Okay. So this is said to be, let me write the definition. This is said to be a joint density. Okay. Joint density function if, first thing, f x comma y, this is greater or equal to 0. I mean, basically you have to check the validity, and double integration, since we are dealing with the two random variables, two continuous random variables. So fxy dx dy should be equal to 1. So this is limits of x, and this is the limits of y. Okay, so if you can recall the week 6 open session, we discussed how to find the limits of x and limits of y, basically. So, okay, and this is the to check, and there should be something piecewise continuous also. Okay, so first of all, how to calculate the probability and all? Let me write a basic definition actually. So for every f x comma y, okay, there exists two jointly distributed continuous random variable. Okay, if you are not getting this definition and all, don't worry, it will be clear in a minute. Continuous. I'm writing this r dot b for random variable. So random variable x and y. Okay, so which will be such that for any two dimensional region A. Okay, it can be anything. Okay. So basically, if you want to calculate the probability, what I'm trying to say basically, probability that your random variable x comma y is jointly distributed in A. How to calculate this? You have to integrate for the region A, and what you have to integrate this joint density. Okay, this fx y you have to integrate. Okay, this is something. So basically, you can say, suppose you have to calculate probability that such that x is lies between -1 to 1 and y is lies between 1 and 2. Then how to calculate this part? This is something you can see. Okay, so let me start with the very basic thing called 2D uniform distribution. Okay, so this uniform distribution, 2D uniform distribution is one of the important topic for your quiz 2. Okay, so this is important. Okay, try to solve some questions from this topic. So what is the definition? I will quickly write the definition and then I will take some examples here. I think there is some background noise. Kiran, can you please mute it?
Sir, hello, sir. Sir,
Yes.
can I ask something? Sir, due to some reason, I was unable to join for week 5. So, there is any place where I can see for the lecture for week 5?
Yeah, so you can find the YouTube links from the calendar itself. Okay.
Thank you, sir.
Suppose there is a region D in R2, okay, and suppose I'm saying if X and Y, okay, this has the joint density function which is defined as basically, okay, are you getting this? Are you getting bored by this theoretical definition, or should I solve the question directly? I can do anything. That's not a problem.
Go ahead,
Go
sir.
like go ahead like
This
this
is
only,
okay,
sir.
right?
Yeah.
Okay. So how to calculate this joint density? So this is nothing but 1 upon area of D, right? This is something you have seen in lectures, such that this X comma Y should be in that D, and it will take value 0 otherwise. Okay. Now, what is the meaning of this thing? So suppose how to interpret the formula. Suppose I'm saying area D. Okay, suppose D is defined like this. Okay, so A, B, C comma D. So what is the interpretation? So this means, what is the meaning of this? So you have X comma Y such that this X will be between A and B and the Y will be between C and D, right? Are you okay with this? You know how to calculate this, right? So let me take very simple example. So what this example says, so suppose I'm saying let X comma Y, okay, is from uniform D. Okay, and what is the D? So suppose D is defined like this, 1 the 1 3. So what is the meaning of this 1 and 2? X lies between 1 and 2 and Y is between 1 and 2. So far so good, right? So if the good approach is try to draw the region. Okay, so this is X, okay, this is Y. Suppose this is 1, this is 2, this is 3, this is 1, this is 2. Scaling please adjust. Should be. So first of all, what is this? X is between 1 and 2, Y is 1 and 3. So this means X is 1 and 2, right? And Y is going from 1 and 3. I'm talking about this region. The scaling should be correct actually. Yes or no?
Yes, sir.
This is the correct way? Yes, no, anything. Simply. Okay, so if you won't say anything, I will
Yes,
simply
sir.
assume you are getting everything, right? Okay, so
Yes,
what
sir,
is the
it's clear.
area of D here? What is the area of D? What is the area here?
6.
2.
1 into, sorry, yeah, 1 into 2, right?
1 into
Which is
2.
1 into 2. Yes,
right?
sir.
So
2.
what will be the fxy? 1 upon area of D, right? So
1
1
by
upon
2.
area of D, this will be 1 upon 2. That's all. This is the way you got the joint density. Okay. We have some questions in the PDF form. Okay, this is the same question I discussed. You got the 3 marks. Okay, the same question I think I discussed by mistake. Right? Okay. Let me see any other question are there or not. Okay, all right, great. What about this question? Answer is A. Just solve it and let me know whether you are getting the A or not. First of all, do you know how to calculate marginal density, or should I discuss the marginal part, then I can move?
We can, sir.
You can?
Yes, sir.
Okay, all right, great then. So basically, marginal is something you have to calculate. You have to integrate the joint PDF with respect to. Suppose you want to calculate the marginal density of x, then what you have to do? You have to integrate the joint density with respect to y.
Y, sir.
Right. So first here you have to calculate the joint density of x and y. Then you have to calculate the marginal density of x and y. Okay. Marginal density of x. So you are getting this part or not?
Yes, sir. Getting, sir.
Let me know once you guys are done.
Done, sir. Option A, sir.
Option A is the correct.
Yes, sir.
Okay. So everyone is getting option A, or others are just waiting?
Yes, sir. It's because we need to find the triangle. So the triangle, the area would be half into 3 into 3. So it's 9 by 2. And
Okay.
fx would be 2 by 2.
Correct. So before that, I will quickly go through the concept of marginal adjacent, and then I will jump there. Okay. So that should be clear. Okay. So what is the marginal density? How to calculate the marginal actually? Color green. So how to calculate the marginal PDFs and all. Okay. So suppose this joint density fx of y is given to us. All right. Then how you can calculate the marginal? This is if I am to calculate the marginal, what I will do, I have to integrate this joint density for the support of y. Okay. If I want to calculate the marginal density of y, what I will do, I will integrate the joint density with respect to x. Okay. Is this clear? And there is something called independence. Don't worry, we'll solve some questions. Okay. So there's something called independence concept. So if you have two events A and B, when you will say these two are independent, if probability of A given B equal to probability of A given B complement is equal to probability of A, means happening or non-happening of the another event doesn't affect the happening of the one event, right? That's the meaning of independence. Yes or no? Right? So if I will write probability of A given B as a probability of A, I will say A and B are independent, right? And you know what is the conditional probability formula? Can I write this as a probability of A intersection B divided by probability of B equal to probability of A? Yes or no? And from here I can say probability of A intersection B is nothing but probability of A into probability of B. So you can see the intersection, I mean the intersection of two events is equal to product of their marginal probabilities. Now, if I will talk about in terms of random variables, so if suppose you have two random variables, let's say x and y are independent random variable. Okay, when I will say it's independent if and only if this joint density is equal to the product of their marginal. Yes or no? Would you agree with me?
Yes, sir.
Right? Or else this conditional equal to marginal. So basically I can say f of y given x equal to x at y, this should be equal to what? F y of y. Can I say or not? Yes, no?
Yes, sir. Yes,
Right?
sir. Yes, sir.
This two are independent. Right? Now, what is the conditional probability? So, conditional is again very simple thing. So, this conditional probability of A given B is nothing but how will you write? Probability of A intersection B divided by probability of B. So, let me write in general. So, if I would like to write F given Y given X equal to X at Y. So, what is the numerator part? This is the joint density, right? So, what else I can write? This I can write Fx of X comma Y divided by f x of x. So what is this? This is joint density and this is marginal. Yes or no? So if you have been given the joint density and marginal, you can calculate the conditional probability. Yes or no? You can do a reverse order also. Means suppose I'm saying x given y equal to y, then what will be the formula? Tell me. It will be joint density of x y and divided by marginal of y. Yes or no? Because this given part will be the denominator. Is this clear?
Yes, sir.
Okay. So actually we are done with the overall formula, major formula of this week 6. Let's try to solve the question.
Sir, sir, once could you go previous?
Okay.
Over here, if it's given that in the conditional f of xy are conditional, then we can write f of x into f of y and cancel out f of the denominator f of y and numerator f of y
Once
and
can
prove
you come again?
To prove independence from conditional. Can we say if they are independent, so the joint PDF would be f of x into f of y independently?
Yeah, so this will be like this.
Yes, sir. Divided by f of y, so we can cancel down f of
Yeah,
y
that's
and f
what
of
this
y.
formula came, right? Then your
Okay,
fx of will cancel out, you will get fy of y.
Yes, sir. Yes.
Okay.
Yeah. I was just confirming. Yes, sir.
Oh, all right. So in this question, what is the good approach? Just try to draw the region, right? So if you see what is the D actually, so see D is nothing but, so suppose I'm saying, let's say this is 0 to 4, suppose this is 1, this is 2, this is 3, this is 1, this is 2, this is 3, right? So x is greater than 0, what is the line of x plus y? First of all, I told, right, just draw the x plus y equal to 3. So x plus y equal to 3 when y is 0, x is 3 comma 0. Basically, it will be 3 comma 0 and then 0 comma 3. Basically, this line I'm talking about.
Yes, sir. Intercept
Right?
3.
And this region is our interest region when x plus y is less than 3.
Yes, sir.
Everyone is getting yes, no?
So can you repeat again? It's too
So
fast.
basically, try to draw the region, right? So if you see in this question, I draw the region of this part, right?
Correct.
It was
Correct.
given in the square. Now it's not
Yeah,
a square. Say x plus y less than 3. So this is line of x plus y equal to 3, right?
Okay.
Understood? And this dotted part, this black, which I'm here using black dots, right?
Sure.
This is the x plus y less than 3, right? Now, what is, first of all, I have to calculate the marginal density of f of x. And we know to calculate the marginal density, I have to integrate the joint density with respect to y. Now, our first task should be to calculate the joint density, right? What is the joint density? We know if for in this case of D, we know what is the joint density, how to calculate the joint density. This is nothing but 1 upon area of D. Yes or no? And what is the area of D? If you see, so area of D is nothing but this is triangle. So half into base into height, which is 9 by 2 only. Yes, no, are you getting?
Yeah.
Right. So what will be the, this is the area of D. So what will be the fxy, this joint density? This will be 1 upon 9 by 2, which is nothing but 2 by 9. Clear? This 2 by 9 is defined when x is 0 to 3. Right. What is the support of x and y? Tell me.
It's 0 to 3.
and y is also 0 to 3 only, right?
Yes, both are 0 to 3.
Basically, I should write here something like that: x is greater than 0, y is greater than 0, and x plus y less than 3. It will take value 0 otherwise. Now, I have to calculate the marginal density of fx. I have to integrate this joint density with respect to y. Tell me from where to where I have to integrate. 0 to
From
3?
0 to 3 minus x.
Correct. So I told, right, if you need, if you have to calculate limit of y, what you have to do? You have to draw a parallel line with respect to y-axis, right? This, if you see, this green line is going from where to where? This is going from, at the x-axis, it will be 0, right? Y equal to 0. So 0 to, from where it will be y equal to 3 minus x. Yes or no? This line is x plus y equal to 3.
Yes,
then what
sir.
is the value of y is 3 minus x. So I have to integrate this 0 to 3 minus x.
Yes, sir.
This will be 0 to 3 minus x, and this will be 9 by 2 dy. It will be 9 by 2 integration of this 0 to 3 minus x dy. Basically, it will be 9 by 2, and there it will be y, and 0 to 3 minus x. And I have to just substitute this value. So 9 by 2 or 2 by 9? No one corrected. It's 2 by 9, right?
Yes, it's 2 by 9. So the area was 9 by 2. So you keep it. So
yeah, so it's 2 by
Inverse
9.
of 9 by 2, sir.
Right, so 2 by 9, 2 by 9, 2 by 9. So basically, this will be 2 by 9, 3 minus x. You can see 2 by 9, 3 minus x is. Okay, clear? Got the idea? Yes, no?
Yes, sir. Yes, sir. Yes,
Sir,
sir.
if we have to calculate the marginal of y, sir, then what was the support of x, sir?
Now you will tell me how will you calculate the support of x? What should be your first steps?
So
I told you, right?
zero.
Okay, no, do not say. What is the first step to calculate the support of x?
Draw parallel line to x.
Draw a parallel line with respect to x, right? If you will draw a parallel strip line to parallel to x-axis, this is going from y x equal to 0 to, what will value of x here? 3 minus y?
Yes, sir.
3 minus y.
To calculate fy of y, what you have to do? You have to integrate this joint density, and what is the limit of x? It will go from 0 to 3 minus y. Basically, at the end, you will get 2 by 9, 3 minus y. That will be the answer. Clear?
Clear.
So can you repeat this finding the limits, sir? This is confusing for me.
This limits, actually, whenever any inequality and all given to you, right? So to calculate the limit, draw a parallel line with respect to that axis. So if you see, I think I have saved this part. Okay. Suppose I have to calculate the probability x greater than y. Okay. Then what I will do? First of all, I will draw a line of x equal to y. So x greater than y will be this region, correct? You can see my pencil. Now, if I want to calculate the limit of y, what I will do? I will draw a parallel line with respect to y-axis. So if you will draw a parallel line with respect to y-axis, so this black part is going from where to where? X-axis, y equal to 0, right?
Yeah, y equal to
0. Right? At axis
yeah.
y equals
y equal to 0.
From 0 to this line, right? This blue line. This blue line is what? This is x equal to y. So value of y will be x. So to integrate 0 to x.
Okay.
Okay. If you want to calculate the limit of x, then if you see this red line is going from
y
to
0. Y to
1, right? Because this upper limit is 1.
Correct.
Correct. Now, similarly, if you see, I have taken, suppose in this case, okay, this y, if you draw parallel line with respect to y-axis, this is going from 0 to, what will the value of this? So this line is x equal to 2y. So limit of y will be x by 2.
Yeah.
If you want to draw the limit of x, it will be 0 to, sorry, not 0, 2y to 1. Because this line, if you draw parallel line with respect to x-axis, this is going from here to here, right? You can see my pencil, direction of pencil. This is 2y to 1.
Okay.
Understood?
Not 1, sir. 1 by 2, no, sir.
Oh, sorry. Yeah, 1 by 2, not 1. No, in case of x, it's 2
2
by 2
x
1,
equal
right?
x
It's 1
equal to
only.
2y. No, sir. For 2y.
2y. This is going from 2 by 2 1, right? X axis.
Yeah, the max
Okay,
value
okay.
of x is 1.
X is 1,
It's
right?
from 2 by 2.
Even it
Yes, sir.
is
Yes, sir.
like this
I was
value.
talking about y. Oh,
No,
sorry.
no, no, no. In this case, y will be 0 to half.
Yes, sir. That I was talking about that. Yeah.
No, no, no.
Sorry.
So
I confused you. I'm really
no
sorry.
worries, no worries. So I would suggest if you have any doubts regarding it, okay, clear. I think who asked this question is clear now.
Sure, sir. Thanks,
Okay,
sir.
okay, yeah. So where it went questions? There is one question. Okay, what about this? Whether you have to check if you want to check the independence. Okay, before that, let me solve this. Okay, just solve this. Value of k is 1. Just check whether you are getting 1 or not. So you
We have to integrate the whole limits, no, sir.
That's what.
0 to 1, 0 to 1 will get
Correct,
k.
correct. So you know, right? This whole integration
Will equal to 1.
will equal to
Area
1, right?
equal to
By
1.
using
Yes,
this, you have to calculate the value of k. Just calculate and let me know whether you are getting this 1 or not.
1 minute, sir.
Because these kind of questions are important. So you should know the concepts. You want to value of constant k.
Sir, value of k is 1.
Okay.
Yes, sir. Got it, sir. It's 1 by 2k plus 1 by 2k equal to 1.
Right?
From there, we'll
Is
get
1,
k.
yes.
So should I solve it or should I move on?
Not required. Not required.
Not required. Okay. So if I will tell you the approach, basically what you have to do, you have to integrate this whole things x plus y divided by k dx dy, since the support of is uh, 0 to 1 and 0 to 1, then this will be, you have to equate it 1 and you will get value of k as 1. Okay, just solve this. Now the next part is you have to calculate the probability x is less than half and y is less than half, right? So what you have to do, you have to integrate the joint density fxy. Since here there is no conditions, right? I can directly the one thing you have to keep in mind,
It was 0 to half both.
0 to half, right? So it will be 0 to half and 0 to half, because upper I'm interested till 1 by 2 only, right?
Yes, sir. We can directly limit out that.
Okay, okay, yeah, okay. So this is very simple equation, right?
Yes, sir.
Okay. Another is, I think this is something I discussed. What about this? Again, you have to integrate this to
Yes, sir. Like the previous k question.
previous one, right? So what you have to do? So because these questions are very similar, so I'm not going to solve. Okay, we will discuss in. So this is dx dy. What you have to do? You have to integrate 0 to 1 and 0 to 1. Just keep
Sir,
in
for
mind. So
x,
if you are
c won't
writing
be coming over
dx,
there.
if you are writing, sorry,
X, its value 1 actually. Constant before x is 1. Coefficient before x.
Before x is 1.
It's not given like c, sir. You have written cx plus cy square, no?
No, this is bracket.
Excuse me.
Okay, sorry.
So this
Sir?
is just keep 1 second. So if you are writing dx here, so this first integration limit it should be for x, and this is dy. So limits for on the second integral should be y for y. Yes, please go ahead.
Can you show me the last question's answer, like probability of x less than half y equal
This
to?
one?
Yes. What is the answer? 1 by 8, na?
1 by 8. You are getting same answer?
Yes, 1 by 8 I got.
Okay.
Thank you, sir.
So I think we have solved the question number 1, 2.
Sir, if
Okay.
the conditional probability x is equal to matlab discrete ho, x is equal to 1 and y is continuous, then how to approach?
That's what I think we did, right? This questions, if you see the question number second, x is discrete, y is this conditional probability, right? Sorry, continuous. This and we solve these questions. Right here, we solve some again question, right? X is the discrete, and x is the uniform, and y was the conditional. Y given x equal to -1. This is the continuous. This is the continuous. Okay, we solve some questions.
No, sir, I am talking about if y is discrete and x is continuous.
Same thing, just a vice versa, right? You can change interchange, then it will be y given, it will be x given y. That's all.
Okay.
Just how this is just a matter of how you are representing your random variable. Okay, so this I would like to emphasize to all of you. Solve this question number 3. There is something smart approach you have to apply, and now this is something you have to think and let me know which.
Sir, since they're independent, so E of xy, there is a formula where E of x into E of y.
Correct. That's what you have to use.
Sir, option C, 8/3.
Wait, very fast. How come? ChatGPT. Right?
Don't know,
yes
sir.
or no?
These questions are repetitive, I guess, sir.
There won't be any penalization. Okay, this is not any. So if you solve on your own, that's better. So yeah, repetitive is okay. The thing I wanted to try to give you the idea how to. I think this question we did in week 5, right?
Might be one of the activity questions. So
yeah,
she
maybe
might have
that's
told
one.
fast.
No, it's fine. I'm not saying, not denying. The what I'm trying to say, you can use this LLM and all for us only, but the thing we need to learn the content for our, say, in exam and all, this is not applicable, right? So if you are using those kind of things, this AI, ChatGPT and all, to learn the concept, then it's better. That there is no harm. Okay, so shall we solve this? Okay, so if you see expected value of x into y, so this is independent. If x and y are independent, we know expected value of x into y. This is same as expected value of x into expected value of y, and we know how to calculate the expected value of x. This is nothing but we have to integrate this x into f of x, basically the PDF of. So it will be 8 times x cube dx. So this is something we have to integrate from 2 to infinity. Yes or no?
Yes, sir.
So it will be 2 to infinity. It will be 8 into x raised power minus 2 dx, right?
Yes,
and
sir.
just apply the formula. Then similarly, expected value of y will be, we have to integrate this y into what is the PDF of y? 2y, and we have to integrate from 0 to 1 dy, right? So it will be 0 to 1 2y cube dy, and you have to solve, and at the end you have to calculate. So 8/3 is the correct answer.
Sir, could you solve E of x, sir? Like I'm getting minus E 8 times x power minus 1 by minus 1. Am I right, sir? In the integration.
And I need to solve the integration part. So I didn't solve. Okay, so those who solve, would you like to explain, or should I?
So is it 8/x cube for E of x?
Yeah, it's 8/x cube, right?
Yes, sir. Yes, sir.
It would be just
I don't know
minus
whether
1 by
it is
x, right?
Yes, sir. Even I'm saying minus 1 by x now. I want you to solve that only for E of x. It's like.
Okay, so what I'm saying, those who have done already can solve it.
It becomes 8 x power minus 1 divided by minus 1. So that
It's
becomes
8/x. Sir.
minus, yeah. It
8/x.
becomes
It's not 8/x cube. It's 8/x.
No, 8/x cube, right? So if I will do x.
Minus 2 plus 1 is minus 1. So
See, if
inverse
okay, one second. If I will apply this formula x is for n dx, so this is x is for n plus 1 divided by n plus 1, right?
yes,
So
sir,
if
but
I want to
minus 1, it is there in the negative part.
Yeah, so this is if 8x minus 2 dx, if I solve this, so 8 x raised to power minus 2 dx. This is 2 to infinity. So basically it will give me x raised to power minus 2 plus 1, that is minus 1 divided by minus 1, minus 1 only, right?
Yes, sir.
Am I doing correct? Now this will be 2 to infinity. So basically you are getting 8, basically
Minus 8 by x.
minus 8 by x, right? So let's make it 1 by x here. So 2 to infinity. So this will be minus 8. If you substitute 1 by infinity minus 1 by 2, so 1 by infinity will be 0. So minus 8 into minus 1 by 2, which is 8 by 2. Right? I think this is correct, right? Basically 4 will be the answer.
Yes, sir. Yes, sir.
Now
Okay,
got
yeah.
the idea?
Yes, sir. It was clear.
Okay. Oh, so this is something we have done. This is something we did. This is something we did. What about this? Will you do the marginalization of x, or is there any smartest approach for this question?
Sir, it's written e to the power minus x into e to the power minus y.
Correct. So basically, this part I can write fx of y, x comma y, e raised to power minus x into e raised to power minus y. This is something fx of x, and this is fy of y. Basically, you can cross check. So if you solve this fx of x, what you have to do? You have to integrate this from 0 to infinity e raised to power minus x plus y with respect to y, right? So e raised to power minus x I can take outside because I'm interested in y only, because then in that case e raised to power minus x will be constant. So it will be e raised to power minus y dy. See, that is one of the smartest approach, but you can cross check here. So it will be e raised to power minus x, and it will be e raised to power minus y divided by minus 1, 0 to infinity. So it will be e raised minus x, and if you solve this basically, so this will be minus, and e raised power minus infinity will be 0, minus of e raised power 0 will be 1. So basically it will be minus, it will be e raised power minus x. So fx of x is nothing but e raised power minus x. Then similarly fy of y will be e raised power minus. Is this clear?
Yes, sir.
Okay, so you can see the questions concepts are same, right? How? Okay, tell me how will you calculate this probability x less than y? How will you proceed for this question?
Draw the line for x plus I. X minus y is equal to 0, right?
Sir, draw the line x equal to y.
Aha, not x is equal to y, and see that part.
See,
Sir, we
Sir,
have
we can do in two methods, sir.
See, suppose this is x, this is y. If you draw x equal to y, basically this will be something like this.
Yes,
right?
sir.
And there is no upper limit, right, on the x-axis and y-axis. This is going from 0 onwards, right? So, and if I need x less than y, this means what? Upper part or lower part?
Upper part.
Upper
It
part
means
or lower?
lower part. It means lower part, no? So
Lower?
the integration limit goes from 0 to y, and from y.
Don't worry about that. Just tell me whether this upper
part, sir.
Why?
X is less
It's
than
lower
y.
part, no? It's lower part because it's x less than y.
just
If we take lower part, x will be greater than y because x is approaching infinity.
Sir, it's the upper part.
It should be upper part.
upper part, right? So basically,
Yes, sir. It is upper part. Clear.
suppose I'm taking any value here. This is x is less than y or greater than y? Less than
Greater.
Y. X is less than y, right?
Oh, sorry. X is less than y. Yeah.
So this upper part is the best one, right? Now, I mean the area in which we are. Now, what I will do? Let's see. If I want to calculate the limit of x. So, what is the limit of x? It will be I first of all what
0 to y.
What should be my very first step? I have to draw a parallel line with respect to x-axis. It will be 0 to
y,
right? And what will be limit of y? Y will be, it can be anything, right? It can be basically 0 to infinity, right? Y can take 0 to infinity, right? Now,
Yes,
what I
sir.
will do, I will integrate. So this is 0 to y fxy, which is e raised to minus x plus y. So this is limit of x. Now, what will be the limit of y overall, right? Which is 0 to infinity. You have to solve this equation. That's all.
Yes, sir. Sir,
Hmm?
can we say also 1 minus probability of x greater than y? Can we do that way also?
Yeah, you can do. You'll get the same answer actually.
Yes, sir.
See, probability x
Since
less than is y is half. 1 minus 1 by. You just cross check
yes,
whether
sir.
it's correct or not. Okay, I won't say in general. Just try it.
Okay, sir. Yeah.
Okay, is this okay to all of you? Did you get the
Yes,
idea?
sir. Yes, sir.
Okay. And there is no need to solve this equation, right? I mean,
No need, sir.
Okay. Okay, so what's the next? So this is something we did. What about this part? Tell me, how will you calculate? Okay, you have 5 minutes to solve this. So just keep this thing in your mind. You have 4 to 5 minutes. You can take 4 to 5 minutes, not a problem at all. But solve this and let me know what is the marginal density. And first of all, what will be the limit of y here?
It should be from 0 to x.
Why not 0 to 1?
Because there is a thing that y is less than equal to x.
Correct.
And x
is less than or equal to 1. That's what. Yes, that's the good approach actually. I mean, that's the correct approach. So you have to keep in mind, it's not something like this. It's written 0 y 0 to 1 and x is 0 to 1, right? Or else if this is something written like this, y 0 is less or equal to x comma y and 1. So this means these two are the same, right? But here there is conditions, right? What y should be less or equal to x. Okay. So
Yes,
what
sir.
you have to do? That's what I just left on you. So basically, what you have to do? Fx of x, you have to integrate the joint density fxy with respect to y. So what is the limit of y? I have to integrate this from 0 to x only, right? And what basically answer is the C answer is
You
the
can answer the 4x cube.
So there is two options. Okay, just keep in mind. So there is a just a difference of support of x. Support of x is the 0 to 1. Okay.
Sir, if they ask like marginal density of y, then the support would be from uh, 0 to x, right, of y.
No. If it's f of y, you have to integrate this joint density with respect to x. So this there is a condition, right? X will
Yes,
be
sir.
from
Y to 1.
y
Sir,
to 1.
we have to take the limits from y, right, sir, while we are doing fx of x.
Yeah,
So,
this is we have to differentiate with respect to y, right?
y, yes, sir, 0 to x. Yes, sir.
Sir, over here, what would be the support of not support? What do you call the limits of f of y, sir?
F of y, okay, so f of y you can take in general, right? Then see that whatever the f of y you are getting, you will get that will be true in general. I mean, for overall support of y. See,
So the support would be from 0 to x, right, sir, of y. I'm not saying the limits after solving everything. Since like over here of f of x, it's from 0 to 1 for f of x. Like that, I'm asking for f of y. What would be the limits at the end?
Okay, tell me what should I write? What should we write?
I feel it's from 0 to x, sir.
Okay, why not 0 to 1?
Because y's maximum value is x only, right?
No. So the thing is, this is something you are saying. This is the total support, right?
Yes, sir.
Okay. Sorry. Yeah. One second. Sorry, I got a call.
Sir, a small doubt, sir.
See. Yeah. One. See, this is something. See. Okay. Why you are not writing this x is y to 1 then?
But we didn't took any value limits regarding x, sir. We took limits from 0 to x. So we have to write 0 less than or equal to y less than
Okay.
or
One second. One second. Let me draw. So this is x, right? Draw your idea. So this will be a straight line actually. So this is 1. This is okay. The upper. So if you see this straight line, so this will be straight, okay? So this straight line, this part This highlighted part is the y is less or 0. The region, this is the highlighted region where this 0 is less or equal to y is less or equal to x is less or equal to 1. Yes or no? Because this line is x equal to y. Okay. So y x will be greater than y, right? Inside the below one, below to this line, right?
Yes, sir.
So far so good. Now,
Yes, sir.
okay, let's say if you want to calculate the marginal PDF of x, what you will do? You have to integrate with respect to y, right? For that, what you will do? You will draw a parallel line with respect to y-axis.
Yes, sir.
This y-axis is going to from where to where?
0 to
0 to x.
0 to x. And in this thing, you can see x is free, right? X can take any value from 0 to 1.
Yes, sir.
So that's what x can take any value 0 to 1.
Okay,
Now, if
okay.
you want to calculate the limit of x, then what I will do, you will draw parallel line with respect to x-axis, and it will be y to 1, right?
Yes, sir. Yes,
Now,
sir.
in this support, you can say y is free, right? Y can take
Yes,
any
sir.
value from 0 to 1. Okay, so this is where you are talking about a whole support. Clear?
Yes, sir.
Without,
It's clear. Yeah. Thank you so much. Yes,
yeah.
sir. It was ambiguous. Yeah.
Oh. How will you calculate this expectation of x? So expectation of x. So the one thing why we give this questions, it will be x into f of x. What is the limit of x? Will you take 0 to x or what? Y to 1 or 0 to 1?
0 to 1.
0 to
0
1,
to 1.
because we have to calculate expected value of x for all the support throughout the support of x. Right? Now I'm not going to do the integration part. Is this all right?
Sir, over here f of x would be from 4x cube only, right? From the previous question.
Yes, this 4x.
Okay, yeah, clear, sir. Yeah, you can go forward.
Okay, this is something we discuss. What about this? Again, the same concept you have to apply. The how will you calculate the value of c?
Integration, double integration from 0 to 2 equal to 1.
Yeah, basically it will be 0 to 2, 0 to 2, cxy dx dy. You have to equate this one. You will get the c as a 0.25. So this is something we can see. Now the next question is based on the above part. Okay. So just read this question. What is the x? X is the temperature change. Let me write here so that you can relate. This is something I would emphasize you to solve. This is temperature change. Okay. And random variable y is, they represent the pressure change during a chemical process. So y is pressure change during a chemical process. Okay, just solve this question. Okay, and let me know whether we are getting correct. So value of c is, okay, let me write down the fxy. So value of
it
c
is like conditional probability, no, sir.
1/4. Yeah, that's what you have to identify and you have to calculate. Okay? So I'm leaving on you guys. Solve this and let me know. So you can take 5-7 minutes, whatever. Okay, so I
So 0.9375.
Yes, so 0.94 is the correct answer.
Yes, a 15/16 answer.
Zero 0.9375.
Yes, I think answer seems correct because it says and correct to two decimal places. You are getting 9375. So till 2 it's 0.94. Anyway, we'll solve this and see. So I will wait for some 2 to 3 minutes so that other people can solve and then we will move on.
Yes, sir. 0.9375 is the answer.
What about others? So I got
Yes, sir. 15/16.
okay. Should I solve?
Up to you, sir. It's clear.
Okay, let's
Please solve it, sir, because we'll also have an idea.
Correct. So basically, it is asking what is the probability that pressure change during the chemical process is more than 0.5. So first of all, I'm saying it is asking probability that pressure change is more than 0.5. So first of all, given that temperature change equal to 0.5. Okay. Because what sometimes people did, they simply say, okay, this is probability x equal to 0.5. Okay, this is a continuous, this will be 0. No, this is not probability. It is not asking probability. This is asking, so there is two different things. If I'm saying probability x equal to at a singleton point is x is a continuous, it will be 0. But if I'm saying fx of 5, so I'm asking what is the density at 5, right? Because density is what? This is mass per volume, right? So that in that case, you shouldn't write the 0 unless it is asking what is the probability x will take exactly value of this. Okay, so how I can write this? Basically, this is something I can write probability y is greater than 0.5 at x equal to 0.5, right? In the numerator part, yes, no, or else let's write like this. This condition I can write fx y, right? Okay, so there will be it will be fx y. X is what is the fx y? Okay, so it is saying fx y is given to us, right? Basically, it should be I can substitute the value of 0.5, right? So this will
Yes,
be
sir.
fx y at 0.5 comma y. This will be 0.5 divided by 4 into y. Yes or no?
Yes, sir.
So basically, this will be 0.5 comma. I'm talking about y greater than 0.5. Just write like this, just to get an idea. Okay. Now, what is the divide by fx of 0.5? Okay. So we need this marginal density first of all. So let's calculate the marginal density. So fx of x, how will you calculate? You have to integrate the joint density fx
With
y with
y.
respect to y.
dy.
What is the limit of y? Limit of y is 0 to
2.
2. I have to integrate this 0 to 2. And what is the this? It's 1 by 4 x comma y. So see, x by 4 I can take outside or not, because x by then x will be constant, right? Because I'm interested in y only. So this will be x by 4. This will be y square by 2, 0 to 2. So it will be x by 8. And if you
4
solve this,
by
this
2.
4 minus 0. So this will be x by 2. right? So fx of x is x by 2. So what will be fx of at 0.5? This will be 0.5 by 2. Yes or no?
Yes, sir. Yes, sir.
Right? So this value we got, and the numerator part we have to calculate. So if you see numerator, what is the numerator part? This is fx y 0.5. Y is greater than 0.5, right? I'm interested in when y is greater than 0.5. So what is this? I have to integrate this from 0.5 to 2, right? And what is this? See here, there is no role of x. I have to integrate with respect to y only. Are you getting my point? So suppose this 0.5 is not given to you. Suppose this is x, then this is x. Then you have to integrate this part. Okay. So now I'm talking about x is say fixed 0.5. So this is 0.5. So 0.5 by 4 I can take outside. This will be 0.5 to 2 y dy. This is the way you did, right? Or anything else?
Yes, sir.
Okay. So basically it will be 0.5 divided by 4, and it will be y square by 2, and you have to substitute this value 0.5 to 2, and at the end you will get the answer. Okay. 0.94 I'm assuming. Okay. Not this value only. Basically this part. What is the value here you got? Point
235.
235, right? And what you have to do at the end? 0.235 divided by. So final answer will be 0.235 divided by 0.5 divided by 4. That's what you did, right?
Sir, 0.235 by 0.25, sir.
It's 0.5 divided by 4, right? Oh, sorry. 0.5 divided by 2. So correct. Not 4. Yeah, basically 0.5 divided by 2 is nothing but 0.2. So if you solve this, you'll get the correct answer. So 0.235 divided by 0.25 will give you 0.9. Okay, you got the idea, right? Conditional probability. You can see the joint PDF divided by the marginal. Clear?
Yes, sir.
Sir, here in this question, sir, can we come to this question, sir? Sir, here I was asking if it was y is equal to 0.5 given that x greater than 0.5. Then that was I was asking.
Again, you have to solve this. Simple. So y, okay, how will you write f y given x is greater than 0.5, right? You are saying, correct? And you are saying 0.5, correct? This is what you are trying to say. So here it will be fx of y, x is greater than 0.5 and y is at 0.5, and divide by fx of, basically you have to calculate it, but it should be like this. Can you think? Here it should be f of x, right? Is this valid?
So, sir, we will have to find the marginal from 0.5 to 1. So, 0.5 to 2.
0.5 to 2 here. This is not a marginal, right? This is a specific part, I think. So here you can see this numerator part is okay. I can integrate for x.
So for the denominator first, we'll find the function for the marginal, then we'll integrate from 0.5 to 2.
That's what, yes. Basically, this is saying, yeah, basically it's nothing but, yeah, this is correct. Very good. Yeah. This is probability x greater than 0.5, right? I can write. So for this, I have to calculate from 0.5
to 2.
Yeah, this is 0.5 to 2, and whatever the f of x dx will be there. Yeah.
Okay, thank you, sir.
Okay, so the next is, this is part I would like to solve. I would like to emphasize to you to solve this question. Because this is something we have done. Similar question. Tell me which option is correct.
D option.
Option D.
Option
D,
D.
sir, 1 by 4. Area is 4.
Okay, so how will you draw? First of all, this is x, this is y. Suppose this is 0, 1, 2, 1, 2. So x is 0 to 2, y is also 0 to 2, right? That means this part, correct? So what is the area of D? This will be 2 into 2, which is 4. So what will be the joint density fxy? This is nothing but 1 upon area of D, which is will be 1 upon 4. That's all. Simple. Clear? Yes, no?
Yes, sir.
Okay. How will you solve this? X plus y less than 2. Probability x plus y less than 2. So just consider this. You have to calculate probability x plus y less than 2. Will you, is there any need to integrate or there is any smart approach?
Sir,
We'll
if
draw
you
one.
have the triangle divided by the whole area.
That would be
There is
the
a line, sir.
First of all,
X plus y
this
equal to 2.
line. See, sorry for my bad drawing here, but please, this should be straight line. So this is the nothing but x plus y equal to 2. Yes or no?
it would be the other way around. That would be x and y intercept would be 2, 2. So that would be the other way around.
Oh, sorry.
And the area inside the triangle would be the one you need to calculate.
So basically, this way, right?
Yes.
Now, what is the probability x plus y less than 2?
The
Below
area
1 or
inside the
above
triangle.
1?
Lower triangle.
The area inside the triangle.
Lower triangle, right? So basically, this probability x plus y less than 2. So I have to calculate this area, right? Simply. So this area is what?
2.
2.
Triangle is what? Half
4 by
base
3.
into height.
4 by 2. 2, sir.
2, right? 2. What is the total area? Is 4.
4.
1 by 2. Right? Or else, what is the another way? Another way, you can integrate, right? So if you want to find the limit of x, so first of all, if I have to calculate probability x plus y less than 2, what will be the limit of x? What I will do, I will draw a parallel line with respect to x, right? So this is going from, see, this is x plus y equal to 2. So this is going from 0 to
2 minus y.
Right? So what I will do, I will integrate this 0 to 2 minus y, 1 by 4, this is dx. And what will the limit for dy? So limit for dy will be 0 to 2 only. Are you getting my point? So this will be 0 to 2, 1 by 4 I can take outside. So basically I have to integrate this 0 to 2 minus y dx. This is dy. It will be 1 by 4 and it will be basically 0 to 2. This is x, 0 to 2 minus y dy, and this will be 1 by 4 and it will be 0 to 2 minus y dy, and you will solve this, you will get 1 by 4 2y minus y square by 2, 0 to 2. So if you will solve this basically, so this will be 1 by 4 and 2 to 4, 4 minus 2 to 4 divided by 2. This is 2 by 4, which is 1 by 2. So you can solve like this also, or else you can simply apply, because this is the area, this is the favorable case, right? And this is the total area. So favorable area divided by total area, means area in which you are interested, and divided by total. That's all. Understood? And suppose you want to do in reverse order the integration. If you want to find the limit of y, then where to where you have to integrate? It will be 0 to 2 minus x. So basically, in this case, what you will do? You will do 0 to 2 minus x, 1 by 4 dy. This will be for dy, and for dx, it will be 0 to. Again, you will get the same answer. I mean, you can cross check. Is this clear? Yes, no?
Yes, sir.
Okay, so we are done with all the questions and the concepts. Hope you got the idea of this content of week 5 and week 6. So anyone have any doubt, or shall we wind up?
So can you post the your notes
PDF.
on the chat window, because I don't know whether it will get uploaded in time.
Sorry, this, I don't think chat window I can share the PDF. It's not possible, right? It's possible. I'm not sure. No, so by tomorrow morning it will be uploaded.
Yeah, actually the video is only coming, sir. The PDF is not.
Yeah.
If you upload the PDF, it will be helpful, sir. Because seeing video.
Sir, it
you
will
and the
be in
problem,
live session
very
notes.
long time.
Live session notes.
Yeah, this will be uploaded under supplementary content, under the section supplementary content, and there will be one section called live session notes. You can find these two on this both PDFs there. Okay.
Sir,
Yes.
sir, my doubt in sixth moment. Sir, I have many times asked you in discourse.
So Dipan, one more thing I asked to share your approach. You didn't try the way which we asked, right?
Sir, what?
Have you tried the way I told you to solve that question?
Sir, I have tried more than 25 times using YouTube, GPT, Google AI. Sir, sir means everything tried, but my answer not coming.
That means you are making some mistake. Okay, anyway, so see, what is the to say that MGF of normal distribution?
Sir, e to the power lambda square sigma square by 2.
E to the power lambda square sigma square by 2, right? So see, how will you calculate the moment first of all? What is the moment? See, if I'm writing expected value of x, that will give me the first moment. If I'm writing expected value of x square, that will give me the second moment. Okay.
Yes, sir.
All right. So, where is that question?
Sir, activity number 8.1, question number 6.
8.1, question number 6. Let me open 8.1. Okay, so one more thing, we are done with the week 5 and week 6. Okay. So, question number 6, right? See, in this question, let me share my screen. See, in this question, this is says what is the value of 6 moment of normal 0, 3. First of all, this is saying normal 0, 3, right? So if you have normal 0, sigma square, then what is the MGF? It's the e raised power lambda square sigma square by 2, correct?
Yes, sir.
So in this case, what it will be? It will be e raised power,
sir, lambda
square
power 3 into 3 by 2.
Into 3 by 2, right? And what is the expansion of e raised power x? It's a 1 plus x square by 2 factorial and so on, right? So if you'll expand this, you'll get 1 plus 3 lambda square by 2 plus, basically this is 1 factorial, but anyway it will be 1. So again this is x square, so it will be 3 square, that is into lambda raised power 4 divided by 4 into 2 factorial.
Yes,
plus,
sir.
It will be 3 cube lambda raised power 6 divided by 8 into 3 factorial. Understood?
Yes, sir. Yes.
Plus so on, right? Now, you see, whenever you want to find the expected value of x raised power r, that rth moment, this is nothing but this is the coefficient of lambda raised power r divided by r factorial in mx lambda formula. Okay, so this is mx lambda. So first of all, what is the coefficient of lambda raised power x? 6 divided by 6 factorial. So here is the lambda raised power 6, right? If I need expected value of x raised power 6, so I to calculate the coefficient of lambda raised power 6 divided by 6 factorial. Lambda raised power 6 you have. How you can find the lambda 6 factorial? Let's focus on this term. So this is 3 raised power 3 into lambda raised power 6. So to find the 6 factorial, what else I have to do? Very simple approach. Just multiply with 6 factorial and divide by 6 factorial, right? So what is the quantity now you will be having? So 3 raised power 3 divided by 8 into 3 factorial into not here, it will be numerator part 6 factorial. Now I can write lambda raised power 6 divided by 6 factorial separate. Yes or no?
Yes,
so now
sir.
just solve this. This is the sixth moment. That's all.
Oh.
Okay.
Sir, means in this we don't have to find the value of lambda.
So what's the point of finding the value? I told you that expected value of x raised power r will give you the rth moment. Okay, this will give you the rth moment. Basically, if you solve this, e raised power lambda square sigma square by 2, right? If you solve this, what it will give you? E raised power x as per the formula 1 plus x square by 2 factorial plus x cube divided by 3 factorial plus x square 4 divided by 4 factorial and so on, right? If I solve this, it will be 1 plus lambda square sigma square by 2, right? Lambda raised power 4 sigma raised power 4 divided by 2 into 2 factorial, right? Basically 4 into 2 factorial and so on, right? Now, okay, let's make it very simple. So if you see, what is the mx lambda? This is expectation of e raised power lambda x, right?
Yes,
If you
sir.
apply this formula, what it will give you expected value of 1 plus lambda x. Can I write lambda square x square divided by 2 factorial plus lambda cube x cube divided by 3 factorial and so on? If you take expectation inside, it will be 1 plus lambda into expectation of x plus expectation of x square into lambda square by 2 factorial plus
Yes, sir.
expectation of x cube into lambda raised power cube divided by 3 factorial and so on. What is this? This is first moment, right? This is
And
second moment. This is third moment. So what is the general things? So basically rth moment, if you see, if I talk about rth moment, which is expected value of x raised power r, how will you calculate? This is nothing but coefficient of lambda raised power r divided by r factor. That's all.
Oh.
Clear?
Sir means I have to go from first term to the sixth term.
Sixth term. But here, if you see, within after the second term only, you will get lambda raised power 6. That means you have to adjust for the another thing, right?
Oh.
Okay, clear? Okay. All right.
Sir, one question, sir.
Hmm?
Activity 5.1, question number 7. Though it is a easy one, sir, but please, why am I not getting the answer?
Okay, how did you try it? What was your approach?
1 by a fx x minus b into a.
Sorry, 1 by a?
1 by a fx of x minus b into a. That is the formula.
First of all, you have to see whether this is monotonic for that or not.
Yes, it is monotonic. It's a straight line.
Straight line, okay. See, y equal to 2x minus 3, right?
Yes.
Okay. So what will be f of y? If what will be the differentiation? 1 upon 2. Basically, it will be 1 upon 2.
Means if it will be 1 upon 2. Yes.
See, gx is what? Gx is 2x plus minus 3. What will be g dash x? This will be 2 only, right? So 1 upon g dash g inverse y will be 2 only, because there is no terms of any x, right? And what is fx of g inverse y? All right. And what is the fx of x? So fx of x is x by 12. So fx of g inverse y will be what? What will value of y here? I mean, what will value of x in terms of y? So this will be x equal to y plus 3 by 2.
Y plus 3 by 2.
So if fx of x is x by 12, then what will be fx of g inverse y in terms of y? Y plus 3 divided by 24.
Yes, 24. Yes.
So this will be y plus 3 divided by 24 into 1 by 2. So y plus 3 divided by 48. That's all.
In the denominator, sir, just a second. Where did you do the calculation? G dash g inverse of y is that y plus 3 by 24.
No. So g dash x is this part, right? So g dash x is 2. So see, what is the meaning of g inverse y? So this means you have to change everything in terms of y. That's all.
Okay.
So g dash x is 2. So g dash g inverse y. There is no terms in x, right? Here I will simply write 1 by 2. Suppose in case this is 2x. Then here you will substitute in terms of y. All right?
Okay.
Okay. Yeah. Okay. All right then. Anything else?
Sir,
What's the idea?
there was a question in GS6, sir. I want to ask.
Which week?
6, sir. Week 6.
Question number. Okay, have you gone through the solution PDF? No.
Yes, sir. I have gone through the solution PDF, but I am not understanding which down part. First question, sir.
Week 6, right?
Yes, sir.
This is independence part you are talking about?
In PDF, sir. Second one, sir. E- Uniform D.
Okay, let me share my screen. This question you are talking about, right?
Yes, sir.
Yeah. What is your doubt?
I asking some graph.
This is equation of circle, right?
Yes, sir. That I know, sir.
Circle will be something like this.
Okay.
Okay. And here, if you see, this is the just a lower half of the part, right? What is the circle? Basically, it's pi r square, right? Area of the circle.
Sir, lower half which one, sir? मतलब ये circle है ना
See,
तो
one
आधा
second.
मतलब
Okay. Tell me where x will be greater than y? This line के नीचे और line के ऊपर?
No, sir. Line के नीचे.
Line के नीचे, right? What is the total area?
Total area, sir. Pi r square.
Pi r square. What is the r?
R, sir. R here. Question 1, sir.
1, right? So it's a pi 1 square the total area, right? Now, what is the numerator part? Favorable, where you are interested in the lower half, right? In the lower, it's a radius is what? 1 or 1 by 2?
1, sir. No, sir. Area radius is 1, sir. But the area
The
area
area is
of
half,
square
right?
by
Area is half because we are interested in the lower half only, not the full, right?
सर माइनस जो होगा मतलब ये पूरा वो लोअर हाफ ना सर्कल का
Yes, this lower half.
Okay.
So similarly, it will be if you are asking probability x less than or equal to y, then you are talking about upper half. Then you have to do like that. Okay.
Okay, sir. Thank you,
Sir,
sir.
sir, week 6, tutorial 2, question number 7. It has asked for a probability and the answer is 2. Can you explain?
Which week? Question week 6, tutorial 2.
Yes, question number 7.
Have you seen the solution?
Yes, I have seen it, but I could not get it. Why is it like that?
See, that is not a probability. It is asking density.
Okay.
So density is mass per volume, right? So basically, see, I told you, right? I think I took one example. So whenever you are saying, suppose I'm saying probability x is equal to 1. So I'm talking about probability at a single, suppose x is continuous, right? I'm saying what is the probability x will take single value, which will be 0. But if I'm saying fx of 1, so I'm saying what is the value of density when x is taking 1. Suppose in case I'm saying fx of x is, let's say, x plus 2 divided by 2. For example, just suppose. That if I will say what is the fx of 1, you will say simply 3 by 2. Okay. So density can be more than 1. It's not about probability.
Oh, got it.
So density is what mass per volume, right? Okay. All right.
Yes.
Okay then. Thanks all. Okay. Bye.
Thank you, sir.
Thank you. Bye bye.
Thank you, sir.
सर रिकॉर्डिंग कहाँ मिलेगा इसका?
Calendar.
Okay, thank you, sir.
Thank you. Bye bye.